focus on water and water remediation. So I'm speaking in context of water, that is contaminated water. So what we do, we take contaminated water, put it, take in a reactor, add some adsorbent material, and then optimize the process for different parameters. We optimize the process for contact time, equilibration, pH of the solution, and several other parameters. So, but then what we do in that process is that we agitate the mixture along with all materials, especially the adsorbent material, and we check when the system is equilibrated, and then we remove it. It's easy to say that we remove it, but then it was like the greatest problem for us when we started thinking of nano adsorbents, nanomaterials for water remediation. Like our inhibition was that how can nanomaterial suspended in water, can it be removed by filtration or centrifugation? We didn't know. We just didn't know. And then I must tell you that BHU, all of you know, BHU is a big university, a wonderful university, which has several departments, all specializations. We have medical sciences, we have material science, we have botany, geology, we have got IIT inside Banaras Hindu University, and we have top class experts here. So my inhibition of starting on this topic was that how a nanomaterial suspended in water could be taken out from the system. My inhibition was that it cannot be done by filtration or centrifugation. So I started contacting people right from one department to the other department where people had done a lot of work on nanomaterials. But my dear friends, I'd like to share with you my experience that research is a very narrow area, very narrow. It's a point of the needle. That is, a person working in an area is expert of that particular task only. It doesn't know many of the other things which are related to the particular topic. So none of the, I mean, to my surprise, I just do not want to name my friends who are learned and then enlightened, but then they had never thought of separating these nanomaterials from suspended nanomaterials from water or aqua solutions. So उनको मालूम नहीं था, वो वही चीजें सजेस्ट करने लगे जो मुझे मालूम थी. तो हमने समझ लिया कि अब ये काम हमसे हो नहीं पाएगा. ऐसी समझ आने से फिर हमने कहा कि चलिए ठीक है, फिर भी हम लोग कोशिश करते हैं. So we had synthesized nanomaterials. We had synthesized by that time when we started nano alumina, nano iron oxide. These were the first nanoparticles which I synthesized in laboratory. Enough amount I had synthesized, but then I didn't know how to separate these particles. So I took a chance, took a material, took a solution of nickel, added alumina in there, and then did shaking and everything, and I put it for centrifugation. Centrifugation, that is at 10,000 RPM for 10 minutes. And I was shocked, surprised to see that it was separated the way activated carbon is separated or some other material is separated. So my problem was resolved. And then over time, I could understand that if it is nano iron oxide, we can separate it from the bulk by simple magnetic field. Put a strong magnet, take a strong magnet and put that container on that beakers or conical flasks, wherever you are carrying out the experiment, it will automatically separate. So, I mean, a new area was open in front of us, a wonderful area. And that area was a particular term, nano adsorbents. My dear friends, we were the first people globally. दुनिया भर में नैनो एडजॉर्बेंट पे काम हम लोगों ने ही शुरू किया. हम लोगों से पहले नैनो मटेरियल अगर कोई यूज होता था वाटर रेमेडिएशन में तो नैनो TiO2 यूज होता था. वो भी फोटो डिग्रेडेशन के थ्रू यूज होता था. जिस तरीके से बाकी मटेरियल्स एक्टिवेटेड कार्बन एल्यूमिना वगैरह यूज होते हैं ऐसे कभी भी नैनो मटेरियल यूज नहीं हुआ. सो वी हैव दिस honor of using this material the way it is used now. So we like started working on this. I published 7-8 PhD theses, but top class publications, that is publications in top class journals. And then फिर तो बाकी कहानी है. उसमें अभी तो तमाम लोगों ने काम किया है. If you look at nano adsorbents today, you will find hundreds or thousands of articles by Chinese, Britishers, Americans, and people from other laboratories. So this was a background of the work which I started working on nano adsorbents. So now also we work, but we prepare nanomaterials. We started working on nanomaterials by preparing through different routes, by preparing through green methods also. We used green methods also for preparation of these nano adsorbents. I just start now. See, my presentation basically would be addressing water and would be addressing metals as well. So a few slides would be there. I'm sure you will like these slides. Heavy metals. Heavy metals are natural components of Earth's crust. They cannot be degraded or destroyed. To a small extent, they enter our bodies via food, drinking water, and air. As trace elements, some heavy metals, copper, selenium, zinc are essential to maintain the metabolism of the body. However, at higher concentration, they can also lead to several problems of health problems of our body. So, heavy metals are dangerous because they tend to bioaccumulate. Because they tend to bioaccumulate. Bioaccumulation means an increase in the concentration of a chemical in a biological organism over time. And compounds accumulate in living things anytime they are taken up and stored faster than they are broken down, that is metabolized or excreted. So, but then what are heavy metals? No, it is a very vague term. It seems to be a vague term, but no, it is already defined. Which metal would you term as a heavy metal or which metal is not a heavy metal? When we talk of environment, we always talk of heavy and toxic metals. The metals are toxic, all of us know. But these metals are essential, like as such categorized as essential and non-essential metals. Essential metals are metals. The earlier slide we discussed this. Say, for example, copper, selenium, zinc, iron. These are essential materials, essential metals. They are needed for our body, and then they maintain the life forms. If their concentration is less, then they result in deficiency diseases. All of us know about this. And then non-essential metals are not needed, but then see, anything which is introduced in ecosystem goes on spreading, like starting from primary producers, be it essential or non-essential, it starts keeping up and up in ecosystem, and then finally gets bioaccumulated and biomagnified. And then if it is a toxic material, it has largest impact on the organism which is sitting on apex of the ecological pyramid. And then all of us know that human beings are sitting on apex of the pyramid. They are at the largest risk. So, but then what are heavy metals? So metals which have got a specific gravity of 5 or more. See, this is included in definition. that metals with a special gravity of 5 or more are termed as heavy metals from environment viewpoint. So if they are toxic, then they are in the category of heavy and toxic metals. Heavy metal toxicity can result in damage or reduce mental and central nervous functions, lower energy levels, damage blood composition, lungs, kidneys, liver, and other vital organs. Long-term exposure may result in many things, including cancer. I'm sure all of us are aware of this. Lead, we take a few examples. So, lead is one of the heavy metals and very well-known toxin. In adults, inorganic lead doesn't penetrate the blood-brain barrier, whereas this barrier is less developed in children. The high gastrointestinal uptake and the permeable blood-brain barrier make children especially susceptible to lead exposure and subsequent brain damage.
Sorry to interrupt you, sir.
Yes, please.
Please make your presentation in slideshow mode.
Okay.
Because some of the participants are saying that, yes, sir. Thank you.
Okay. Acute exposure to lead is known to cause proximal renal tubular damage. Long-term lead exposure may also give rise to kidney damage. Another toxic metal is arsenic, very well-known toxin. It is a widely distributed metalloid occurring in rock, soil, water, and air. Inorganic arsenic is present in groundwater, which is for drinking purpose. Organic arsenic compounds such as just a minute. Such as arsenobutane are primarily found in fish, which thus may give rise to human exposure to this particular metal and have after effects. Another small description I would like to share with you about arsenic. You will find that a lot of discussion, lot of monitoring of arsenic has been carried out globally. And if we talk of Indian continent, then the entire stretch of this India, entire stretch of West Bengal, Bangladesh, Sri Lanka, it is badly affected by arsenic. And there is one gentleman, Professor Deepankar Chakravarti. I'm sure a few of you might be knowing him. He is known for bringing this problem in front of people. Long back, he started working on monitoring of arsenic and then published high quality papers. He's in Jadavpur University, Kolkata. But then, if you look at the remedial part, that is not there. Some remediation is proposed, but then, as such, it is not there. And the most important part of arsenic poisoning in that particular catchment is that it is geogenic. It is not man-made. If it is man-made, we can enact some rules, regulations, or rather rules and regulations are already there. India is the first country globally. India is the first country to introduce environmental legislation in its constitution. But then it is there. It is a fact. But then its implementation is not that tough. It is not very rigid. So, but it is already there. Like control of pollution by legislation is one of the modes of control of pollution. So this arsenic poisoning is well known, but then its remedies are really not there. There must be some remedy where you just, like we are dealing with people who are living where there is no electricity. So you cannot go for the water treatment plants there. No electricity is there. You can provide them a small portable equipment and tell them that you put water from here and then take affluent water which is free from arsenic. This is what is needed, and some efforts are already there. Government is making some efforts, and then that part also we can discuss. So uncertainties in estimation of past exposures are important when assessing the exposures response relationship. But it would seem that drinking water arsenic concentration of approximately 100 micrograms per liter also leads to cancer and leads to some other problems, including skin cancer and then the gastroenteritis problems. Another important metal is cadmium, which is also very toxic, found in zinc smelting, waste material, e-waste, paint sludge, incineration, and combustion of fuels. It is toxic at even at extremely low levels. In human, long-term exposure results in renal dysfunction. Cadmium is also associated with bone defects, osteomalacia, osteoporosis, spontaneous fractures, increased blood pressures, etc. It's a small slide you can see which depicts problems because of excessive intake of cadmium. Mercury, very toxic. Mercury compounds, it was used in prehistoric cave paintings for red colors and metallic mercury. Used there. It has several applications. In medicine, apart from previously mentioned use of mercury as a cure, syphilis is a contagious disease. Mercury contagious means it is a disease which is caused uh, sexual organs. No, mercury compounds have also been used as diuretics and are having lot of applications at industries as well. Acute mercury exposure may give rise to lung damage. Chronic poisoning is characterized by neurological and psychological, such as tremor, changes in personality, restlessness, anxiety, sleep disturbances, etc. Renal dysfunctions are also caused by mercury exposure. Organic mercury, say methyl mercury poisoning, has a latency of 1 month or longer after acute exposure, and the main symptoms relate to nervous system damage. High doses may lead to death, usually 2 to 4 weeks after onset of symptoms. Like, I'm sure that anybody who is in this study of water pollution control knows the term Minamata. This catastrophe was reported in Japan in 1950 and was caused by methyl mercury poisoning from fish contaminated by mercury discharges to the surrounding sea. Minamata was first discovered in Minamata city in Japan in 1956. It was caused by the release of methyl mercury in industrial wastewater from a particular industry's wastewater. In the early 70s, more than 10,000 persons in Iraq were poisoned by eating bread baked from mercury polluted grain, and several thousands people died as a consequence of poisoning. However, the general population does not face significant health risk from methyl mercury exposure, with the exception of certain groups with high fish consumption. In early 70s, more than 10,000 people. This is done. Organic mercury is rather more toxic. As of March 2001, 2265 victims had been officially recognized as having Minamata disease, and several of them died. Water pollution. We are discussing of water pollution. We can see that how this water cycle moves. Any alteration is simple definition. I just don't read this. This is a cycle, water cycle. You can see that water is used practically for each and every application. Is there a shortage of water? No, it is not there. Then what is the problem? Problem is with fresh water. No? If we take a unit of 100, then more of the water is contained in oceans. 97% of water is contained in oceans. 97% is contained in oceans. And it is less than 1% of water which is available for readily available for application. And what are applications of water? The best application is potable purpose. पीने के लिए जो हम पानी यूज करते हैं, और agriculture, industry, and then disposal. So remember, when we talk of industry, see, it's easy to say potable purpose is okay. Potable and domestic applications, खाना बनाते हैं, नहाते हैं, ये सब domestic application में आते हैं, and these are superior applications. And then industry, agriculture, agriculture जैसे पानी हम पीते हैं उसी तरीके से क्रॉप्स को भी इरिगेशन की जरूरत पड़ती है. बिना पानी के फसलें नहीं हो सकती. और जो हमारे यहाँ फसलें कुछ जगहों पे कम होती हैं या ज्यादा होती हैं, उसके पीछे सबसे बड़ा कारण इरिगेशन, वाटर इरिगेशन, वाटर फॉर इरिगेशन, इसकी जरूरत की वजह से कम या ज्यादा होती है. पंजाब में सबसे ज्यादा होती है क्योंकि पंजाब में नदियों की भरमार है. 5 नदियां हैं और इरिगेशन का पानी बराबर मिलता है, फ्रेश वाटर मिलता है. बाकी जगहों पे जहां नहीं मिलता वहां पे फसलें कम होती. इंडस्ट्री, there are few industries which are water intensive. Say for example, textile industry, pulp and paper industry, and then beverages, steel manufacture, and then drugs also, drug production, pharmaceutical industry. In pharmaceutical industry सबसे ज्यादा पानी जो है वो ड्रग के प्यूरिफिकेशन में कंज्यूम होता है, बहुत ज्यादा पानी कंज्यूम होता है. सो वो भी एक वाटर इंटेंसिव इंडस्ट्री है. और सारी की सारी इंडस्ट्री जो 1% पानी है उसी पे डिपेंड करती है. तो फिर सॉल्यूशन क्या है? सॉल्यूशन क्या है? सॉल्यूशन इज नॉट एक्सट्रैक्टिंग मोर एंड मोर अमाउंट ऑफ अंडरग्राउंड वाटर. और पानी में भी जो हमारा अंडरग्राउंड वाटर है ना, जो नीचे से खींचते हैं, कुएं से निकाल लिया या पंप से निकाल लिया, दैट इज द बेस्ट क्वालिटी वाटर. उसमें केवल आपकी डिजॉल्व्ड ऑक्सीजन लेवल कम होता है, बाकी सारे पैरामीटर्स एकदम बराबर होते हैं. तो फिर सॉल्यूशन क्या है? सॉल्यूशन निकालना नहीं है. मई जून के महीने में हमारे जितने भी बड़े बड़े शहर हैं, दिल्ली हो चाहे कोलकाता हो चाहे मद्रास हो चाहे आप जहाँ रह रहे हैं बीकानेर हो जयपुर हो, वाटर टेबल इतना नीचे पहुंच जाता है, 250-250 फीट नीचे पहुंच जाता है. पानी नहीं निकलता, पंप पानी खींचता नहीं है, उसमें आपको और लंबा पाइप लगाना पड़ेगा. तो कितना लंबा पाइप लगाएंगे? और नीचे पाइप लगाते जाएंगे, वहीं फिर ये सब आर्सेनिक और ये सब प्रॉब्लम शुरू हो जाती है. अगर आपका पानी किसी ऐसे एक्वीफर से आने लगा जो कंटामिनेटेड है, नेचुरली कंटामिनेटेड है, तो फिर तो प्रॉब्लम ही प्रॉब्लम है. तो सॉल्यूशन वो नहीं है. सॉल्यूशन तो है वेस्ट वाटर ट्रीटमेंट एंड इट्स रीयूज. यही सॉल्यूशन है. जो पानी आपने निकाल लिया, यूज कर लिया, यूज करने के बाद उसका ट्रीटमेंट करिए, फिर उसका रीयूज करिए. जब हम रीयूज की बात करते हैं तो ये रीयूज कहीं भी हो सकता है. रीयूज का मतलब इनके एप्लीकेशन पॉइंट्स क्या है? जो बेस्ट एप्लीकेशन पॉइंट फिर से पोर्टेबल पर्पज है. ये आप ट्रीटमेंट के बाद उसे उसकी क्वालिटी एसेस करके उसे पीने के पानी के तरीके से यूज कर सकते हैं, या इंडस्ट्री के लिए भी यूज कर सकते हैं, एग्रीकल्चर के भी यूज कर सकते हैं. और जब देखें कि इन सब में यूज करने लायक नहीं है, देन वी गो फॉर फाइनल एप्लीकेशन, एंड दैट इज regarded as disposal of water. Disposal of water, I always say it is an application because जो डिस्पोजल है वो भी ऐसा नहीं है कि आपने पानी यूज किया और फेंक दिया, नदी में गिरा दिया, नहीं नहीं, उसके भी स्टैंडर्ड्स है। अगर आप इंडियन स्टैंडर्ड की बात करें तो वेस्ट वाटर जिसमें 250 मिलीग्राम पर लीटर से ज्यादा डिजॉल्व केमिकल ऑक्सीजन डिमांड है, उसे आप डिस्पोज नहीं कर सकते। मतलब ये हुआ, जब पानी आपने यूज कर लिया, वेस्ट वाटर जब वो हो गया, तो आप अगर आपने फाइनली ये तय किया कि इसके ट्रीटमेंट में बहुत पैसा खर्च होगा, तो आपने तय किया कि हम इसे डिस्पोज कर देते हैं। तो डिस्पोज करने के लिए भी पहले आपको उसके कुछ कैरेक्टरिस्टिक्स मेजर करने पड़ेंगे, जिनमें से एक कैरेक्टरिस्टिक है केमिकल ऑक्सीजन डिमांड। इसकी मैं डेफिनेशन बताने की जरूरत नहीं समझता, ये सारी की सारी किताब की चीजें हैं। तो केमिकल ऑक्सीजन डिमांड मेजर करिए, एंड इफ यू फाइंड अकॉर्डिंग टू इंडियन स्टैंडर्ड्स, if wastewater, if the treated wastewater is containing chemical oxygen demand less than 250 milligrams per liter, that can be disposed. अगर 250 मिलीग्राम पर लीटर से ज्यादा सीओटी है, केमिकल ऑक्सीजन डिमांड है, तो आप उसे डिस्पोज नहीं कर सकते, उसका ट्रीटमेंट करना पड़ेगा। सो सॉल्यूशन तो फिर यही निकल के आता है। ये फिर से मैं छोटी सी स्लाइड बनाया है, ये मेटल पॉल्यूशन के इफेक्ट से अभी हम लोगों ने आर्सेनिक और
Sorry to interrupt you, sir.
यस प्लीज।
Our participants are from South India, so they are saying, sir, please speak in English
Okay, okay. I thought
because they are from
I
other
thought
state, other
no,
than Rajasthan.
I thought they are from Bikaner. No problems.
They are from South India, you know. So
Okay, no problems. No, it's most welcome. That I mean, we should use a language which is like which everybody understands. So no problems. So health effects of
thank you,
metal
sir.
pollution we have already discussed, and then see these are the sources of water pollution: sewage and domestic waste, agricultural discharges, fertilizers, detergent, toxic metals, and radioactive materials. See, radioactive materials we keep apart because it has come up as a big area as far this water pollution is concerned. So we don't discuss that in this particular presentation. Metallic pollutants we have already seen, but then let me just put it in front of you. Metals are essential. A few metals are essential. Say, for example, iron and then magnesium and all these metallic species. And then metal probably non-essential to living systems. Metals are toxic to some life processes and they are highly toxic to the systems, which we have already discussed. So then, right now we discussed that. Well, what are the solutions? What is solution to this is scarcity of fresh water. Solution certainly lies in the concept of treatment of wastewater and reuse. So this is a big statement, treatment of wastewater and reuse. So wastewater, my dear friends, wastewater is one of the most complex material, one of the most complex materials. That is, several PhD theses, hundreds of PhD theses have been completed on this particular aspect of characterization of wastewater. So when this material is complex, its treatment is rather more complex. So when we talk of treatment, then we should keep in mind a very clear understanding, because more of the treatment technologies are very expensive. They involve qualified manpower. Men means men and women both. They require time, they require land, they require money if instrument or chemicals are needed for treatment. So this choice has to be very, very important. That is choice of a particular treatment technology. Well, how do we proceed there? See, you have been hired as an environmental expert by an industry which says, sir, madam, we have a scarce water. So please tell us how easily how economically can we provide treatment to our wastewater and can reuse it. So that wastewater has to be properly characterized. Wastewater has to be characterized for all possible parameters, which as an expert, you understand that you should go for it. See, there are 54, 55 water quality parameters, and you cannot go for analysis of all those parameters. It is basically your common sense that find out what is the industry, and then see, if you look at today's era, you can understand that practically for all industries, characterization of water is available. But then find out water is from which industry, or which are several industries which are giving out that water. Note down the characteristics, and then find out the target application. Ask the industry that, okay, where this particular treated wastewater is to be utilized. So industry people will tell you that it has to be diverted for agriculture, or it has to be diverted for some industrial application, or maybe that they say that it has to be finally disposed. So on that basis, you have to decide a particular treatment technology. So treatment technologies basically are three: pre or primary treatment, secondary treatment, and tertiary treatment. Pre or primary treatment, I'm sure that some of you who are into this subject are knowing, are basically pre-treatment, basically prepares wastewater for subsequent treatment. Secondary treatment typically is a treatment which takes care of biochemical oxygen demand. That is, this brings down biochemical oxygen demand, BOD. But then if toxins are present in wastewater, BOD, that is secondary treatment, cannot be employed just like that. And then tertiary treatment. The main treatment of wastewater is tertiary treatment. But then for tertiary treatment, water has to be prepared employing primary treatment and secondary treatment as well. So we come on to this slide that there are different technologies for treatment of water, metal-rich water, ion exchange or reverse osmosis, or reduction or precipitation or membrane filtration, flocculation, or for that sake, adsorption as well. These are different treatment technologies which are already available. A lot of literature is available on these treatment technologies. I have italicized this term absorption because my talk relates to application of nanoadsorbents, and the nanoadsorbents are used through nanoadsorbents are used through absorption for water or wastewater remediation. See, academically and practically as well. Academically, I should understand why I'm going to use a particular technology. This is very important. If you ask me why going for nanoadsorbents, then I should have an answer. Otherwise, it's of no consequences because several treatment methods, several treatment technologies are already available. So, well, I should justify application of nanoadsorbents for water remediation. So, how? Let us try to find it out. Why adsorption? Why adsorption? So I should say it's a very good method. It involves less money. It doesn't require a high-fi qualified personnel. I can say this, but then I can also tell you what are the disadvantages of the other technologies which we have listed on the earlier slide. So these technologies which are there, they are involving high operational and maintenance cost. Not all of these methods, but some of these technology involve expensive equipment, And then incomplete metal removal. When we talk of metal removal from ecosystems, then I must tell you that it's not very difficult. Removal of metals is not very difficult. But then removal of trace amounts of metal is a big problem. That technologies cannot remove, more of the technologies cannot remove metal from aqueous solutions if they are present in very small amount. So incomplete metal removal is one of the problems of these treatment technologies. Another disadvantage is generation of toxic residual metal sludge. Generation of toxic residual metal sludge. इतना सारा this much of amount of metal sludge would be uh, evolved after the technique has been done. So it's a problem, it is a disadvantage. And then disposal of toxic sludge is another major problem. When the sludge is generated, where would you dispose it? You cannot leave it open. You cannot dump it underground. You cannot dump it in brine systems. So when they are there, what in separation process we are doing? We are trying to accumulate a toxic material from a larger volume to a smaller volume. In each case, it happens, and then that has to be properly disposed. So disposal of toxic sludge is another problem with more of these processes. Now, advantage of adsorption. Why adsorption? Like I will say that these technologies are having problems, and then adsorption is a very good technology, blah blah. But then it's a fact. Adsorption-based processes can remove metallic ions more reliably and efficiently than any of these conventional treatment methods. Adsorption-based process is not very expensive, doesn't require very expensive equipment. Adsorbent generation can make the adsorbent regeneration can make the treatment cost effective. That is, reuse of that adsorbent material is possible. That is, after the material has been used in a process, it can be regenerated and can be reused. But then it is not that the same material can be reused 100 times. No, on each regeneration, it loses some efficiency. And after you find that its efficiency, it's better to replace the material. You have to again get rid of this material and then dispose it and use the fresh material. So now adsorption. So adsorption can be done only when adsorbents are there. So it's a list of adsorbent materials. Activated carbon, all of you know, it is derived from cellulosic material, but it's a long process from cellulosic material. You have to draw carbon, fixed carbon, and then you have to add catalyst materials, and then it has to be activated. When what happens in activation, it develops pores, surface area enhances enormously. That the material which we know as activated carbon. So the entire process of activation makes the material very expensive. So it's a problem. It becomes a problem that small vendors cannot use it, cannot afford using activated carbon because of its high cost. So then research started on search for alternate adsorbent materials. So in that particular series, so many waste materials were used as adsorbent materials. So that particularly takes care of waste disposal, like application of waste material as well for water remediation or for remediation of contaminated air as well. So fly ash, chitosan, zeolite, iron oxide, sphagnum moss, kaolinite, wollastonite, sawdust, seaweeds, activated alumina, soya cake, red mud, etc. Materials have been successfully applied for water remediation as adsorbent materials. Then, like the topic of today, like wonderful materials. Nano-adsorbents, the wonderful materials. Why? What is need of the new adsorbent material? See, basically need is there because we anticipate that uh, maybe the new material which we are going to design is cost effective. Maybe it is more efficient. So these are the basic needs, no? And then new adsorbent. There is always a need of a new adsorbent. Otherwise, we would not have, never have done it after activated carbon. After activated carbon, hundreds of new adsorbents have come. So need is basically there are varieties of adsorbents which have already been used for removal of metallic pollutants from waters, aqua solutions, and most of them are having low efficiency, and they are because of low efficiency, they may be cheap, but then they cannot be reused. So they finally incur a lot of cost on the user. But the reuse capability of conventional adsorbents is not very effective. So the development of new adsorbent materials for removal of contaminants, especially high metals, is really needed. And then nanotechnology, today's important talk. Nanotechnology has many applications in different fields, say, but recently it has started using it in water remediation. I think we are all aware of this particular approach. Top down or bottom up. टॉप डाउन और बॉटम अप, एक बहुत बड़ा सा पार्टिकल लेके उसको छोटे पार्टिकल में कन्वर्ट कर दिया, नैनो रेंज में कन्वर्ट कर दिया, या बहुत छोटे पार्टिकल को लेके हमने उसे बड़े पार्टिकल नैनो साइज में कन्वर्ट कर दिया. टॉप डाउन, that is larger to smaller. Mechanisms and structures are miniaturized to a nanometric scale. Bottom up, we just say that smaller to a larger one. We begin with nanometric structures such as molecule, and through a process of assembly or self-assembly, we create a mechanism larger than that of with the particle with which we had begun. Increased surface area provides, like nanomaterial provides a lot of surface area, very large surface. It's a small depiction that if we take a 1 centimeter cube, a cube of 1 centimeter, 1 centimeters dimension, then its surface area is only 6 centimeters square. You just crush it in, make it in millimeter cubes, then total surface area comes to be 60 centimeters square. And if you again, if you put bracket in a 1 nanometer cube, then its surface area becomes 6 multiplied by 10 raised to the power 7 centimeters square. So this is a small depiction that how smaller size is, or how a nanomaterial helps increasing surface area. So this is what we exploit. Exploiting, say exploit is not a good term. This is what we use as far our nano-adsorbent, formation of nano-adsorbent, synthesis of nano-adsorbent is concerned. Naturally occurring nanomaterials such as volcanic ashes, ocean spray, magnetotactic bacteria, mineral composites, and other exist in our environment. Incidental nanomaterials, also referred to as waste particles, are produced as a result of some industrial processes. The third category of nanomaterials is engineered, where we work, where our people were like in the task of application of nanomaterials for different aspects, from different applications are working. So third category, nanomaterials, engineered nanomaterials. Engineered nanomaterials are sub-classified by type of basic material and its use: metals, semiconductors, metal oxides, nanoclays, and quantum dots. Quantum dots, all of us are aware. So we can see this. Engineered nanomaterials are organic or inorganic. If you look at fullerenes, are well known now. Carbon nanotubes, fullerene C60 to C70, number of carbon atoms. Carbon nanotube, multivalent carbon nanotubes, or single valent carbon nanotubes are known to all of us. Inorganic metal oxides, metals, quantum dots. And further, we have zinc oxide, ceria oxide, silver, gold, nanoparticles, etc. Carbon nanotubes are materials of great concern, have several applications, and can be synthesized now easily in laboratory. But then see, problems come with how pure the material you have synthesized is. So different methods, how material bulk is there, how a nanomaterial could be synthesized. Several methods are there. Inert gas condensation, spray pyrolysis, flame synthesis, sol gel synthesis, co-precipitation, electrodeposition, sonochemical method, solvothermal method, reverse missile technique. These are methods which are now established, well known and established now. So you can use any method depending on uh, your resources. Nanomaterials can be defined as materials which have its elements crystallized or molecule in 1 to say 100 is large one, less than 100 dimension range. Nanomaterials can be used as adsorbents for water and wastewater remediation, which we are using very efficiently, and that is witnessed by top quality publications, journals globally. Due to small size, nanoadsorbents have high surface area. They have high catalytic potential and high reactivity, which make them better than those of usual materials. Due to high surface area, nanoadsorbents have the greater number of active sites or interaction by different pollutant species. This particular point is very, very important. The surface area becomes higher. So that larger surface area offers a larger number of active sites on the surface. And these are basically the active sites where the action of adsorption occurs. That is where the contaminant species adhere. To get better results for removal of metallic species from wastewater, nanoparticles are becoming alternatives for treatment of wastewater. So this slide depicts particular method and then for which particular nanoadsorbent it has been used. So alumina nanopowder is very efficiently synthesized by sol gel method. Nanocrystalline magnesium aluminate is very successfully synthesized by thermal decomposition. Anatase nanoparticles by solvothermal method. Zinc nanoparticles by sonochemical synthesis. TiO2 nanoparticles by laser pyrolysis. Zinc oxide nanoparticles by laser ablation. Ceria nanoparticles by flame electrospray pyrolysis. And CO nanoparticles by reverse missile technique. So are easy, well known and then established methods. Like if you want to synthesize a particular nanomaterial, you can adopt any of these methods which are listed here. So formation of nanorods from nanodots. This is like that. This is article published in Language is a Journal of American Society. Interested in more details, you can refer to this. It's an article of 2007. Synthesis of nanoflowers. We worked on nanoflowers, I think, in today's discussion, I'll discuss where we use this for water remediation, synthesis of nanoflowers from ZNO, zinc oxide nanorods, like we get in 25 to 48 hours. We get wonderful materials. Illustration showing the growth of mechanism of zinc oxide nanoflowers. You can see this schematic, how this finally comes in form of uh, zinc oxide nanoflower, which can be successfully used for water remediation. Removal of metallic, see, this is the work which we carried out so far, which we reported, which we published in different journals. So metallic species, removal of metallic pollutants, metallic species by different non-organic materials. So chromium and lead are very successfully removed by zero valent iron. Chromium by surface modified Jacob-side nanoparticles. Cadmium by thiolactic acid modified titanium dioxide nanoparticles. Cobalt by magnetic chitosan nanoparticles. Arsenic by afagnite nanocrystals. Copper by chitosan bound Fe3O4 magnetic nanoparticles. And then again chromium by maghamite, and then cobalt by iron oxide and gamma iron oxide. Copper by gamma Arabic modified magnetic nanoparticles. Chromium by these two nanoparticles. Zinc by gaganite nanocrystals. Arsenic, chromium, copper, nickel, cadmium, arsenic. They have all been very successfully removed, and their mechanism has been illustrated. Well laid down methods and mechanisms have been already reported by us. Absorption of magnetic separation, absorption and magnetic separation of mercury on functionalized nano iron oxide magnetic polymers. So this is what we carried out 2015. So it's a schematic. I'll just upload this. I'll upload this slide to Madam Tanu Sharma, who can pass it on to all of you. It's again the adsorption of magnetic separation. I'm sure you are enjoying these things. These are related to mechanism, how the contaminant goes onto the surface of the synthesized nanoparticle. LLMI grafted multivalent carbon nanotubes for H2S removal. So you can see that finally H2S is bound onto the surface of nanoparticle and then is removed. Clay encapsulated ZnFe2O4 nanocomposite for adsorption of pollutants. So small schematic. We published this work in 2015 in RSC Advances. RSC Advances is a journal of Royal Society of Chemistry. So, I mean, a few slides I'll be displaying here. The highlights of work which we carried out, this particular work. It's basically work done in my laboratory. And then that student, Dr. Varsha Srivastav, she moved to Finland in Lappeenranta University, and now she's changed the university. She's a professor at Finland these days. So she did PhD with me in probably in 2011 or 2010. So the work which we published during that Varsha, and then another Deepak was also there, who worked on nanoadsorbents. So this work is related to synthesis of study of synthesis and application of nanoadsorbents for water remediation carried out by our research group. So It is engaged in synthesis of variety of nanoadsorbents, especially for water remediation. Variety of nanoadsorbents, say, for example, nanoalumina, iron nanoparticles, silica nanoparticles, zinc oxide nanoparticles, zirconia nanoparticles, nickel oxide nanoparticles, iron oxide loaded silica nanoparticles, that is Fe3O4 and SiO, that is iron oxide loaded silica, malachite nanoparticles, magnesium oxide nanoflocs, polypyrrole coated telluride nanoparticles. I mean, and many more. No? These are a few which we are trying to put in front of all of you. So some small discussion I'll be presenting, and that discussion would be in terms how this is how the particle is synthesized, and then how better is the particle, how better is the nanoparticle for the application of water remediation, especially for a particular contaminant which you have chosen for the experiment. So the first work which I'm going to report is synthesis of nanoalumina from chromium and nickel removal from aqueous solutions. See what happens, what happens. We usually work on single solute systems. We usually work on single solute systems. See, anybody who is working on absorption or even on solvent extraction or other separation processes, like uh, working on multi-solute systems, maybe of some industrial application, but then it's very difficult to decipher the mechanism. More of the work you will find on single solute systems, and then those single solute systems are extrapolated for water and wastewater. So wastewater, I mean, I try to repeat that it's a very complex system, and then there are several restrictions, several assumptions, several deletions to if you want to understand what mechanism would have been there. So first slide where we discuss the nanoalumina, we discuss nanoalumina for removal of chromium and nickel. So nanoalumina, which we have synthesized through Solgen process, and this nanoalumina powder had a diameter of 20 nanometers, a surface area of approximately 79 meters squares per gram, with a porosity of 0.51, density 1.33, and then pH/ZPC 7.9. Each one of this parameter, particle dia, BET area, surface area, porosity, are all these very important parameters. And I'm sure that all of you are aware of this. But then I try to discuss, I mean, for all of you, I do not mean that you do not know, but there may be a few students in the gathering. Uh, Dr. Anu, are there students attending this particular program?
No, sir.
Okay, teachers are there.
Only teachers are there.
Oh, then enlightened teachers. So, but even then, I'll discuss this particular parameter because when I started working on this, it was tough for me. So, pH/ZPC, it's very important. Like, if we work on powders, pH/ZPC is a very important parameter. It's like pH at which surface of the adsorbent material is electrically neutral. When I speak this, I'm sure that the entire fraternity which is attending this program would understand everything. But then I'll further explain that if we are provided with the adsorbent material, and if we like absorption, see is such a method, is such a technology which is not very difficult to work on, in the sense that it's easy. It can be performed in any institution. What I mean by institution is that a place where you do not have much of the facilities. But then there are few things which we must understand very clearly. So PHZPC is one such parameter. Another parameter is ionic strength, which I'll discuss right now. Because many of us go on committing mistakes about optimization of the process. If we have committed a mistake, we should not commit it after we know about it. So pH is a pH of solution at which surface of the adsorbent material is electrically neutral. Now things become very clear. We just make a surface, we try to visualize a surface which is electrically neutral, zero charge. So what will happen? Below in a solution, if we go on changing pH of the solution, then we have determined pH is a well-known method of determination of pH at PC, not very difficult. It's a metric method. So we have also reported, if anybody is interested, they can follow our articles or they can do it with articles published by several other researchers. So if we know that pH ZPC of a adsorbent is 7.9, so now you have suspended the material in a solution. What we do normally, we go on changing pH of the solution. What we report there is basically we maintain initial pH of the solution. We maintain initial pH of the solution, which is not very correct. But see, this is what we do. So how the adsorbent material would react, that is very important to understand. If we know this parameter of pH at PC, we can probably predict many things about it. We can predict many things. So in case pH ZPC of solution is 7.9, then we'll vary pH. If we make pH of solution below 7.9, the surface of the adsorbent material would be deprotonated, and above pH ZPC, surface will be protonated. Or in simpler words, by the knowledge of pH ZPC of adsorbent material, we can understand that what will be impact of solution pH on yield of the process, on removal of the material, on removal of the contaminant from the solution. So this is very important. Another parameter which like I would like to share with you, Dr. Anu Sharma, and with all the participants is ionic strength. It's very important because like when I started as a student of 21 years old, when I joined my PhD long back, I committed mistakes and I got very unacceptable results. I just could not understand. I performed experiments with lot of precaution with double distilled water. Rishi, remember? Remember, when we work on metals, we should always use double distilled water or even a better water. If it is from other water systems, like it's not necessary that we get distilled water. We can have developed water systems as well. Those water systems, facilities are also providing excellent quality of water. So we have to ensure that, because any contamination, when we talk of environment, we talk of parts per million and parts per billion level of metallic species. And then if we do not understand sincerity of this, then it's really our purpose of doing any research on metallic species forfeited. So ionic strength. Ionic strength of solution is a very important parameter. So I just could not understand what mistake I was committing, because I should have got stable results. At a particular range of concentration, I was getting satisfactory results. But beyond that, I was not getting. So I just reviewed the literature, and I found mention of this parameter in one of the books, not in a research article. In a research article, I found that the scientist had, the research worker had maintained ionic strength. But this, I just made a study, serious study on this parameter of ionic strength. So ionic strength, mathematically, ionic strength is defined as half sigma Ci Zi square. Half sigma Ci Zi square. Ci is concentration of the cation or anion, and then Z is charge over this. This way, ionic strength of a solution can be computed. So what do we do? No, when we optimize a process, we go for OVAT, one variable at a time. What we do at this particular OVAT is that we fix all other parameters except one parameter for which we are going to study the impact. So what mistake I was committing was that I was fixing all parameters and was varying one parameter without knowing that there is another parameter, ionic strength, which can also be important. So especially in case of metallic systems, ionic strength is a very important parameter. But if it is some organic contaminant, say for example pesticide, then ionic strength, okay, important, but doesn't have impact on the system. But if metals are there, then this is very impactful parameter. So that ionic strength also has to be very properly taken care and managed. And how it be managed? This is another very important question. If some of the participants ask me, I will respond. Otherwise, I just inform you that it is important parameter and must be taken care. So this is a characterization of this nano alumina powder, which we synthesized. So you can see it is like particle size determination by transmission electron microscopy. And then second picture is X-ray diffractogram, which shows that it's crystalline in nature. Second system which we made a study was on removal of nickel by nano alumina. So I just briefly try to depict the results. What happened? These are the conditions. Concentration was 25 to 75 milligrams per liter. Adsorbent dose is very important. That is very small adsorbent dose, and then it gave us very important results. Say important in the sense that we can see the value of Q, that is absorption efficiency, and percentage removal. Effect of temperature, we can see that all the time. If you look at the y-axis, the removal of the material is nearly, say, more than 90, 95 in best conditions. Effect of pH, you can also see that at around pH 7, we have the best, pH 6, we have the best removal of the material. So nanoalumina was synthesized by salt gel. See why we adopted salt gel. It's also very interesting and important. In salt gel, no, we go for precipitations and making the gels, and then finally treatment of the gel. So what basically happens is that we get the best quality material. We get the material in purest form if we adopt salt gel, and it is quite economically viable. Surface area was around 79 meters squares per gram. Removal process followed pseudo-second order kinetic. Values of coefficient of mass transfer, like what finally happens, the material from soluble phase goes onto the adsorbent surface. So it is significant and are indicative of a sufficiently rapid transfer of adsorbent species from bulk to the surface and solid liquid interface. Activation energy was found to be 8.96 kilojoules per mole, and nano adsorbent alumina was quite efficient and gave us very good results. This is regarding chromium by nanoalumina. Chromium by nanoalumina. So we can see, if you look at this graph on the left side, we have percentage removal, not very high, but not less as well. It is around 80% of removal in this case. Under these conditions, effect of adsorbent dose. In each case, we had very small adsorbent dose, which speaks of efficiency of the material which was synthesized for the process. Effect of temperature, we can see that by temperature of 298 to 318 Kelvin, chromium concentration 2 milligrams per liter, 50 ml. This is what the amount of solution we took, and the adsorbent dose was 0.50 grams per 50 ml, and then contact time was 150, that is equilibration time was 150 minutes. Effect of pH, we can see in acidic range chromium is removed at more efficiency. These are the research highlights. A contact time of 60 minutes we did it for 150 minutes, but then 60 minutes for equilibration time. This is, an achievement as far as these adsorption processes are concerned. And then another point I would like to share with you, my experience and a fact. Sure, all teachers are attending, so they might be knowing that if you will find two types of articles as far as adsorption is concerned, that those two types are where you find very large time for equilibration. See, large time means 4 hours, 24 hours, 5 days, 6 days. Or you find a few articles where you have 20 minutes, 40 minutes, or in this case, 60 minutes for equilibration. So the two types of processes are different. Both are, we say adsorption, but then one is the process where it is surface adsorption. But then the other process where you find that time of equilibration is very high. That is like a diffusion controlled process. Like pore diffusion, if we look into the mechanism, then pore diffusion plays very significant role in all those cases. And pH of the solutions affected removal of chromium, and removal decreased from 90 to 60. That is, say, for example, approximately 61% by varying pH from acidic to alkaline range. Process of removal was governed by pseudo second order kinetics. Value of activation energy was determined and was quite significant. Thermodynamic parameters were also determined, and then it showed that it is spontaneous and then exothermic in nature. See, more of the adsorption processes, be it a macro size adsorbent or a nano size adsorbent, more of the adsorption processes follow exothermic process. Energy is evolved. Findings of present study reveal that nanoalumina can be effective adsorbent for chromium 6 from aqueous substances. This is nano iron, like studies on nano iron for chromium and nickel. So we had PSZPC of 7.1. It's very, very important. It's very important from industry viewpoint that PSZPC 7.1. We have not to work hard there. We have not to struggle to maintain a particular pH for a particular higher removal. This is PSZPC 7.0 neutral range. So these are depictions of XRD and TEM. You can see that XRD says it is a particular crystalline in nature. And then iron. So we did magnetic studies as well and surface studies as well. And two nitrogen adsorption desorption isotherm, and then hysteresis for nanoparticles. Hysteresis loop for magnetic nanoparticles was measured at room temperature. Saturation magnetism of sample was 55.2 at room temperature. Value of MS is comparatively lower than that of bulk magnetite, which is 93. Thus, value of reminiscences and corrosive forces was found to be 1.2. It's important academically. And then nickel from nano iron particles. You can see this parameter. What we did was that we optimized concentration and contact time and optimized temperature as well. And then effect of pH, you can see that 2, 4, 6, 8, 9, 8 at 8, and then finally it goes up at pH 8.0. We get the highest amount of removal as far as this nickel is concerned, and affect adsorbent dose. We go on increasing adsorbent dose, get but it is debatable. It is debatable. That is it true that if you go on adding more and more amount of adsorbent, then removal will go on increasing? No, it is not always there. There are several reasons. If you go into mechanistic aspect, there are several reasons of this. So these are research highlights for nano iron particles for removal of nickel. Adsorption was highly dependent on pH. Each case we find that pH dependence is there. And then percentage removal of nickel was higher at lower nickel concentrations. This finding is of industrial application because industries in affluence, we do not find very large amount of nickel or these metallic species. Adsorption decreased from 90 to 88 by increasing concentration from 5 to 15 milligrams per liter. Adsorption data followed Langmuir and Frederick isotherm models. Maximum absorption capacity was found to be 11.53 milligrams per gram. And then endothermic, like more of the cases we find are the cases of exothermic nature of the absorption process. But in this case, it was like relatively uncommon finding. Relatively uncommon finding. So it also says that, see, this pore diffusion is an endothermic process. So it also indicates that the process, the mechanism would be largely controlled by pore diffusion. If it is endothermic, see, by using thermodynamic parameters, we can really understand whether it is exothermic or endothermic. If you find it is endothermic, it speaks automatically that the process must be pore diffusion controlled. This is chromium removal by nano iron. So I have another few minutes. So concentration, optimized concentration, we optimized adsorbent dose, we optimized pH as well, and other parameters. So the research highlights. Just let me see what is last 76. So I'll have to go faster. Okay. Highlights are increase from chromium removal, increase from 88 to 99 by decreasing initial concentration from 15 to 5. Removal of chromium found to be highly pH dependent, and maximum was at pH 2.0, but difficult because maintaining a pH of 2.0 in a natural system is very difficult. It will have a lot of impact on the aquatic fauna flora. Absorption increased by increasing temperature shows endothermic nature. Here also it is endothermic. Thermodynamic studies reveal feasibility of absorption reaction, and also confirm endothermic nature of chromium removal process. The absorption studies showed that the nano iron can be effective. Yeah, of course it is effective. But then see, this pH of 2.0 is very tough to maintain natural treatment processes. It says zinc oxide nanoparticles for water remediation. What we did, you can see XRD of zinc oxide. It's a TEM image to find out its particle size, and then it's like depiction of removal by the concentration dependence of the removal, and we can see that at 200 uh, milligrams per liter concentration, we have got say around 90% of removal. This is again very important. Highlights are nanoparticles, how we synthesized by sol gel, XRD and TEM are carried out to understand whether it is crystalline or amorphous or its particle size. It was in the range of 18 to 31 nanometers. It speaks that nanoparticles process is very properly done, and then nanoparticles which are synthesized are very good quality. FTIR particles confirm presence of specific absorption peaks of zinc oxide bond, and then the zinc oxide particles zinc oxide particles displayed significant efficiency for removal of cadmium from aqueous solutions. This study indicated that zinc oxide particles can serve as excellent materials for cadmium from aqueous solutions. And then this work relates to synthesis and application of nano-magnesoferrite MgFe2O4 for the removal of cobalt from synthetic wastewater. This is again XRD and TEM, and then AFM of the surface of nanoparticle. And the research highlights say that removal efficiency is investigated. TEM confirms the size in the range of 25 to 35 nanometers. VT surface area was 55.83 units, and it was observed that removal decreased from 97.7 to 81 on increasing concentration from 200 to 500 milligrams per liter. Removal of cobalt was found to be dependent on pH and remarkably increased from 80 to 99. So other highlights tell us suitability of this material for removal of cobalt, synthesis and application of copper carbonate nanoparticles for removal of chromium. Characterization, we did XRD and then TEM to find out the particle size of the material which we synthesize. For surface area determination and to gas absorption desorption graph, and then SEM image of the synthesized absorbent material. And this is like another work where we optimized the process of removal by using response surface methodology. This is one of the methods, one of the tools where you can bring down number of experiments drastically. So we did that. I'm not going to discuss this, and if any of the participants are interested in making a study on response surface methodology, they can follow our articles, and if they find any problems in following those articles or any of the results, they can contact me. So this is again related to that application of malachite nanoparticles for treatment of printing press wastewater. This is we synthesized, we took wastewater from printing press and then simulated that particular wastewater in laboratory also, and then we had wonderful results, and we published this result, published also. So nanoparticles synthesized by treatment for treatment of wastewater from printing press, VT surface area was 87 units, and then CCD was employed for optimization for absorption parameters. ANOVA demonstrated that the regression model was highly significant. That is like there was hardly any difference in the predicted results and the results which we obtained in our experiments. Optimum conditions for 99%, it is almost 100% removal of synthetic wastewater at pH 6.5, an initial concentration of 5.550 milligrams per liter. It's very important. This particular 1, 2, 3, 4, fifth point is really very important, which made our article important for the journal and for the industrial community as well. Langmuir absorption capacity was found to be very high at 87.7, very high capacity value. Negative values, which we did this thermodynamics, and then we obtained negative values of Gibbs free energy, pointing out spontaneous nature of the process. And as nanoparticles are found to be efficient after regeneration, like these nanoparticles were regenerated, and then we used it without much loss of efficiency up to 5 runs. So divide this cost by 5, like adding some cost on regeneration, but then finally it tells us that regeneration brings down cost of treatment drastically. And then this is what also very important. While discussing today's lecture, today's discussion, I tried to point out that we did this green synthesis as well. So this made the work rather more important. So green synthesis of magnesium oxide nanoflower and application for removal of divalent metallic, several metallic species we worked on for removal. So MgO nanoparticles synthesized by chemical precipitation method and then treated with different concentration of acacia gum to develop flower-shaped MgO nanoparticles. Treated with 10%, 20%. So, I mean, if you adopt this method, you can also synthesize the particles which we synthesize. And this is characterizing some images of the absorbent material. So you can see this, how schematic, how these nanoparticles were prepared, how we got the nanoflowers. Yeah, negative charge surface group of nanoflowers. I mean, it's simple to adopt as well. And then different studies highlights like average diameter of these particles was, I mean, 36 is okay, but 108 and 190, I mean, are not nano, but then their results were quite appreciable. Surface morphology was observed and was quite different for these particles. Nanoflowers, I mean, absolutely different. PSZPC was determined, and then it was 10.67, 10.8, 12.4 as well. Absorption studies demonstrated that nanoflowers are capable for the removal of cobalt, cadmium, zinc, copper, manganese, lead, and nickel from synthetic wastewater. Faster removal was observed for all these species. Present approach has the advantage of low cost, biocompatible absorbent materials for the abatement of divalent metallic species synthetic wastewater, and can prove to be an economically viable alternative of costly activated carbon and other costly absorbent materials. Synthesis of NIO nanoparticles for removal of cobalt. I mean, this is characterization part, XRD and TEM, and then PSZPC determination. Like what I was saying, it's not very difficult. We have done this. We have very clearly reported this determination of PSZPC for absorbent materials. So anybody who is interested can certainly adopt the method, and then if they find any like blurred depictions, they can contact us. We'll be happy to clarify. So this is again response surface methodology, central composite design. I'm not going into details of this. And then effect of different cations and anions. Like what happens if you add some cations and anions from outside, or if some cation. We made this study because I gave a statement that wastewater is a very complex system, and then it's not one particular anion which is present in solution, which is present in water, for which we are going to make studies. There are several others, hand of materials are there. So what happens if we add a few cations and anions? We did that. We added chloride, phosphate, sulfate, carbonate, and nitrate, and reported the results. Particles, I mean, 20 to 30 nanometers diameter, excellent particles, synthesized at 500 degree centigrade calcination. Flaxseed oil, see this green synthesis, flaxseed oil, which also known as linseed oil, was used as surfactant. Response surface methodology was used, ANOVA, chemisorption mechanism. all the teachers are enlightened and they know this chemizo option and physical adsorption are. I'm not going into those details. That so absorption was quite all right, and then these are absorption capacities telling that yes, this material is all right, and then these are the highlights. Thermodynamic parameters were determined, and nanoparticles were also found to be efficient for removal of cobalt in presence of lead, manganese, cadmium, copper, and zinc. And anion effect study showed that anions like chloride, phosphate produce least effect on cobalt removal, while sulfate, nitrate, and carbonate decreases removal. And then synthesis and application of another material, polypyrrole coated telluride, for removal of uh, anionic food dye, tartragine, and divalent metallic ions. So I'll just, I think, few minutes left. Characterization slide. This is again the SAM images, SAM images. And then this is the effect of pH on removal of tartragine, effect of solution pH on absorbent surface, effect of initial concentration, removal of metals from single solute, and multi-solute systems like we added cations and anions and then reported the removal. It's like more often academic, rather industrial interest, because when the system becomes very complex, it's very difficult to solve those differential equations which we get. No, it's not. I mean, many times we are not able to solve those equations, and then we don't get results at all. So, but then industry is okay. Like industry may be interested in how much is the removal, and that we can report by simple determination of residual concentration in the solution. These are research highlights. No, our brick-like morphology having 30 nanometer diameter and 425 meters square per gram is certainly a we call non-crystalline material, amorphous material. Synthesized particles found to be very efficient for removal of tartragine from solution. Acidic medium was found to be favorable. Endothermic, I mean, diffusion control. Adjusted dye-loaded nanoparticles act as an efficient absorbent for removal of divalent metallic ions, which is added from outside. These are research highlights. And then just like I go for the last highlight, that study indicates versatile nature of polypyrrole coated telluride nanoparticles, which was found to be efficient for tartragine as well as for metallic species, which make it a strong candidate for treatment of dye-laden, especially tartragine and metal-bearing wastewater. So, I mean, my very dear friends, and Dr. Anu Sharma, Dr. Amit, this is like what?
Yes, sir. Yes, sir.
Can I complete this?
Yes, sir. Yes, we complete, sir. We continue, sir. There is a time.
I complete and then you can ask any questions. A wide range of nanoadsorbents, like this is like we did over several years, maybe 6-7 years. No, after that we switched to other topics. No, but then this is what we did. That a wide range of nanoadsorbents how we synthesize for several metallic pollutants: chromium, nickel, cobalt, cadmium. We didn't like as far nanoadsorbents are there. All of you understand this arsenic, mercury, nitrate, and fluoride. These are different types of materials. So we did not try, because if we like looking into chemistry, we did not try our materials there, because if we look into the chemistry viewpoint, our materials will not be effective there. The materials should have been functionalized to be effective for removal of those contaminants. Nanoadsorbents are found to be effective even in presence of other metallic species. Not many metallic pollutants, nanoadsorbents were quite efficient for the removal of organic pollutants. I mean, we worked on tartragine only, and we stopped working on particular topic. And nano adsorbents have potential of reuse, regeneration of adsorbents, can make the treatment cost effective and also can solve the problem of sludge. Because when you use it several times, if you use it twice, you are, decreasing sludge at least up to the half of the sludge which would have been produced by using a fresh material each time. Further, application of biocompatible, low-cost precursor can make adsorbent materials environment friendly. And then publications to be made in the journals. We might have made 50 publications from outcome of the work which I have tried to put in front of you. So I just try to stop here and request all of you to pose any questions. If I know the answer, the question is not very difficult, I'll be able to answer. Anu
Sir,
Sharma?
there is a question in the chat box, sir.
Yes, please tell me the question. Chat box. Can you read the question, please?
Yeah. How far it is a developed and absolute material which can work for all water contaminant at once, or is it a never-ending process? Pankaj Gog, Shivja College.
It is not possible. It is, my dear friends, it is not possible. It is not possible that we develop one material that is a universal material and that would be suitable for everyone. Not possible at all. Otherwise, there would have been no development. I developed activated carbon. See, if you use activated carbon for decontamination of nitrate and fluoride, it simply does not work. So when it does not work, I work in laboratory for 20 hours a day and come up with a new adsorbent material, come up with a nano adsorbent and then put it in front of you, put it for the industry that yes, I have done this, use this now. So my dear friend, it is not possible. Well, we have a material and then see, with the slight knowledge of chemistry, we can think what will happen. We can functionalize the material, but that would be new material then. So your question is really very good, and then tells us that, well, you have to further go for working on the topic and then developing materials. This rise of materials, be it drug delivery, be it environment, be it any other area, you have to develop material. So my dear friends, according to me, no, we cannot have a universal material which can take care of all contaminants.
Okay, participants, any query, please unmute your microphone or write your query in chat box.
Yeah,
if you have
sure.
any question,
Please.
Ask any question.
I think I could not generate interest in the participants.
Okay, sir, there is no any query, sir.
No problems.
Dear participants, if you have any question, please write it in chat box.
Write it in the chat box, or you can send it to Dr. Anu Sharma or Amit, and then I'll be happy to respond to the query whichever comes in front of me.
Sir has described the best method of rectifying the water pollution, wastewater pollution. So then please ask any question.
Okay, sir, there is no any questions.
Okay, no problem.
Then we will stop the session. It was my pleasure to get a glimpse of your knowledge. We will grateful to have a deep in your knowledge in future also. Thank you for being a part of this wonderful session. Thank you, sir. Bye.
Thank you, Anu. Thank you very much. Namaskar.
Thank you, sir.
Namaskar.
Okay. The second session will be started from 11:30. We in the online mode. Okay, sir. Thank you, sir,
Okay,
for your
namaskar.
nice lectures. Okay.
Namaskar. Thank you.
Next session will start within 5 minutes. There is bio break of 5 minutes. Good morning, Praveen sir. Am I audible to you, sir? Bhumika ma'am, am I audible?
Yes, ma'am, you are audible.
Yes, ma'am, you are audible, ma'am.
Praveen sir, am I audible to you?
Yes, yes, ma'am, you are audible.
Yes, ma'am, you are audible.
Very clearly.
Okay, ma'am. Praveen sir, are you able to unmute yourself? There is some technical issue with sir. We are rectifying this and session will start within few minutes. There is some technical issue with sir. We will start the session within few minutes because there is some technical issue.
Good morning, ma'am.
Morning, sir.
Good morning, ma'am.
Good morning, sir.
Because of some technical issue, na, which I cannot
Yes,
connect
sir.
to the audio through
Uh,
WebEx on my
No
laptop.
problem, sir.
So I will just try to connect it with the laptop through my this phone, and then I will try to
Okay, sir.
the class.
Are you able to share your screen, sir?
Just a minute. Ma'am.
Okay, sir.
Hello.
Yes, sir.
Hello.
Yes, Praveen, sir. Ji, sir.
Am I audible, ma'am?
Yes, yeah, you are audible, sir. Are you able to share your screen?
Is this screen
Sir, first
visible
of all, I stop my sharing.
on the camera? Camera.
Okay. Sir, we are not able to see you. Yes, sir.
Now the screen is visible.
Yes.
No?
Now your screen is visible.
Actually, I can take
Uh,
not working properly. Yeah. And the which meeting is not getting started. I have to take on the phone and this. Is it okay, ma'am?
okay, no problem, sir. It is
Okay.
fine, sir.
Thank you, ma'am. Okay. So
Dear
we'll start with
participant, please pin the presentation. Sir. First of all, I will introduce you. Bhumika ma'am.
Yes,
Please
ma'am.
handle this session. Bhumika ma'am and Haim ma'am, please handle this session.
Yes, ma'am. Yes, ma'am. Pleasant greetings and good morning to all. On behalf of the FDP family, I would like to extend my warm welcome in today's second session of 5-day online FDP on recent trends in green technology for sustainable development, sponsored by AICTE. The current session is on biodiesel and overview of some alternate sources for its production. Our keynote speaker is Dr. Praveen Purohit, sir, Assistant Professor, Head, Department of Chemistry, Engineering College, Bikaner. My pleasure to introduce you, sir. Sir has a teaching experience of more than 18 years, including 6 years of PG teaching. Sir is shouldering many responsibilities of NSS Program Officer, ISTE Faculty Advisor, Nodal Officer, Ek Bharat Shresth Bharat Mission, and Head Chemical Testing Lab, Bikaner. Sir has completed many projects and has published many papers in journals of high repute. Sir has contributed to corporate life and management of the institution by holding many administrative posts, including registrar, head, establishment, and many more. Sir has contributed in starting MSc Chemistry and establishing CERDC Bikaner at Engineering College, Bikaner. Sir, we are eager to listen from you and get enriched by your rich experience. And over to you, sir.
so the participant has to bear some kind of the inconvenience that has been faced. I'll try my level best to explain this thing. So we'll start with what is actually this biodiesel and the related thing. And thank you very much, Anu ma'am, for giving me the opportunity. Though I'm not presenting it in a proper manner as it was required by this, but somehow due to this technical reason, the problem that I am facing actually. So actually, it's indeed an honor that you have given the opportunity. And thank you very much, Anu ma'am, and the Bikaner Technical University, the college, CET, and all the other colleagues that are organizing, the team that is organizing this FDP. Now, starting with the session, actually, the figure that we are seeing here is actually the sun, the ultimate source of the energy that is actually present in the universe. Now, when we speak of this energy, it is present in this form, the natural body that is the celestial body that is present, and then it is actually utilized by all other living organisms, and then it is actually the ultimate. It is actually the ultimate source of uh, energy that has been utilized by the various organisms. Yes. Now, if you look at the spiritual energy that is actually present in the universe, and it is also plays a very important role in the biological system, as well as what we observe, what we actually carry out. Now, this energy actually is available in the form of these electromagnetic radiations. Now, the electromagnetic radiation that are actually present is actually, as we all know, that rays which consist of electric and magnetic field, and all of them arranged in a particular wavelength, in a particular sequence that they are being arranged, and it consists of various kind of rays like gamma rays, X-rays, ultraviolet, infrared, microwaves, and the radio waves, etc. Now, the beauty of this is that they all remain united, and it depends on what part of this energy radiation is actually utilized by the person or the living organism or the system that is actually utilizing this radiation. Now, see, if you look at the visible radiation, then it is actually the
Sorry
Vibgyor
to
that
interrupt
actually
you,
forms.
sir. Sorry to interrupt you, sir. Your PPT is not visible, sir. Your presentation, your slide is not visible, sir.
I'm on the camera mode, so is it visible now?
No, sir.
Just a minute. Now is it visible? Is it visible now, ma'am?
Yes, sir. Yes, sir.
Okay. So when we speak of the radiation, when we speak of the electromagnetic radiation, then we know that the various wavelengths they are arranged in the increasing and the decreasing order of the spectra as ever you consider whether it is frequency or wavelength. So this is actually what we actually utilize. And if we consider the electromagnetic radiation, then we can see that in late 1800, James C. Maxwell postulated that instead of the visible light being composed of small tiny divisible particles of the matter as it described by Newton in his corpuscular theory of light, it was comprised of electromagnetic waves. As you can see, the blue and yellow lines, which actually depicts the electric and the magnetic field. Now, the most important thing here is that these two components have the wavelength and frequency perpendicular to each other, and it is actually the interaction of this electric and magnetic field with the matter that actually causes a drastic change, kind of change, whether it is regarding chemical composition or orientation or something like that, so that energy changes can take place and it results in the development of some kind of system changes. See, the same thing when postulated in the other form is actually there was another scientist who actually proposed that if you look at the important relation E is equal to hc by E is equal to hc by lambda, then you can clearly see that when you have this variation and you arrange these radiations in the form of increasing energy in case of the atomic orbits, then actually what we observe is that you can see that the electronic transition takes place between these various energy levels. And when the energy transition takes place, it jumps to a higher energy, it jumps back to a lower energy, and then a particular set of energy in the form of the photon is actually released. So there is an absorption, there is a release of the energy. Now what we are discussing is actually these are the basic concepts of the energy that has been utilized, that has been involved in the system. And the Planck stated that the energy increases in the whole multiples and never in decimals. That is actually the main Planck's theory. And as a multiple of the photon that the energy is observed. Now we are saying photon. So not to forget the great scientist Einstein, who actually proposed another theory that is actually the photoelectric effect, which is somehow related with this energy radiation only. Now, we can see that when we speak of this, we use the Planck revolutionary idea to explain the photoelectric effect and propose that light was made up of the tiny particles which are called as photons. And these photons are then actually absorbed by, light photons are absorbed by a metal, say sodium metal. They absorb the energy, the electron get ejected from the surface. And this is actually what is observed in the photoelectric effect. And when we speak of the photoelectric effect, we actually observe the same thing. That is actually how changes takes place. And we learn from the Planck, only form of the light undergoing the absorption of the wavelength can use the transition from ground state to the excited state. It may be any form of the radiation. And in case of, suppose there are double bond, triple bond, then UV or something like that. So we can see there is an similar manner, in case of the living organism, the energy is observed Now, this is actually the simple basic process by which actually the solar energy is absorbed, is utilized by the living organism, and as a primary consumer of this light energy are the green plants. If you look at the green plants, they actually absorb the sunlight and utilize the carbon dioxide and water nutrient that are present, and in the presence of the chlorophyll, they actually convert it into the light energy into some usable form, that is actually the glucose, and convert it into chemical energy, which is then actually utilized. So photosynthesis is a process used by plant and other organisms to convert the light energy into chemical energy that can later be released to the fuel the organism activity. This chemical energy is stored in carbohydrate molecules such as sugar, which are synthesized from carbon dioxide and water. Now, see, if you go into great detail, that is the simple equation, carbon dioxide is plus water in presence of light and the photosynthetic pigment chlorophyll. It is converted into glucose, oxygen, and energy. The oxygen is then utilized by the living organism. Now, see, overall process of the photosynthesis, if we compare, if we look at, then the overall process of synthesis is the energy transfer in the chlorophyll, and these are the thylakoid membrane, then the transfer of the electric energy, electrons in the photochemical reactions, and then finally the thylakoid membranes, again the electron transport chain and ATP system again takes place in the thylakoid membrane, and the carbon fixation and exports of the stable product. Now, we are speaking of this photosynthesis and the photosynthesis efficiency for the reason that we will discuss why we are emphasizing in this is it is actually the portion of the, you can say, the earth, which actually utilizes the maximum amount of the solar energy and converts into a form which is usable to convert it into some other productive. If you look at the energy equation, then we can see that the energy of a photon is given by E is equal to hc by lambda, and where c is the velocity of the light, lambda is the wavelength of the light, h is the Planck's constant, 6.626, 10 raised to minus 34 kilojoules per mole. And looking to this equation, the energy E of the Einstein of the molecule can be calculated. That is actually the 1 mole of the molecule. Avogadro number multiplied, you get 28600 by lambda. Now the point to consider here is that the greater is the lambda, less is the energy. That is the important point that needs to be considered here, where E is in kilocalories and lambda is given in nanometers. So an Einstein of red light with a wavelength of 680 nanometer has an energy of 42 kilocalories. But if you look at the Einstein of a blue light, it has a shorter wavelength and therefore the more energy than a red light. So what is the, regardless of whether the light is blue or red, the same number of the Einsteins are required for photosynthesis per mole of oxygen formed. So that is actually the main thing that is involved. And the part of the solar spectrum that is used by plants has an estimated mean wavelength of 570 nanometer that we all are familiar. We are studying in this class 11, 12 notebooks also. Therefore, the energy of light which is used during photosynthesis is approximately 20 this. So energy which is used in photosynthesis, in order to compute the amount of energy involved in the photosynthesis, one other value is needed, and the number of the Einstein absorbed per mole of the oxygen involved. This is called as the quantum requirement. We'll not go in the great detail of this, but we will actually consider that why we are discussing this particular fact. So this is actually the molecule of the chloroplast, the chlorophyll molecule, and the process of the plant photosynthesis take place entirely within this chloroplast molecule. And there are two reactions, the light and dark reactions. And if you summarize, the light reaction occurs exclusively in the thylakoids, and the dark reaction occurs in the stroma, the soluble enzyme of which catalyze the conversion of carbon dioxide and minerals to carbohydrates and the other organic molecules. Now, let's see, if you look at the pigment systems, there are pigment 1, pigment 2 systems. Not concerned more here, but simply we will see what happens when you consider the light is absorbed, it is utilized in the light reaction and undergoes that the molecule, energetic molecule undergoes Kalman cycle, carbon dioxide fixation takes place and the molecule of sugar is produced. We have to emphasize on this step that how light energy is getting converted into chemical energy and stored in the plant as sugar. Now, it is the human which should have the efficiency of utilizing this sugar, which has stored energy in it, to convert it into some form which is usable. We are discussing this because we would like to get an alternative to the petroleum fuel which is being utilized for energy. Now we will come to the energy which is stored, and it is called as the bioenergy. Now the bioenergy term consists of two terms. Actually, the bio, that is related to the living organism, and energy is the amount of energy which is associated with this. If you speak of bioenergy, then you can see that we have different sources of bioenergy. That is the plant oils or sugary starch parts of the crops. Then we have another material that is actually the you can say the types of the wood chippings or straw. Then you have you can say animal waste, cow dung, etc. And then you also have an important thing that is from the used cooking oil. You obtain from the used cooking oil a kind of the blended finished fuel that is actually the biodiesel, the waste cooking oil. And then you also have another important thing that is algae. In a nutshell, if you consider all these things, that is these different sources of energy, these different sources of energy are actually are actually dependent on living organism only, and the different products that are present in the living organisms are being utilized by the same human being, and they are using this. So this is actually the energy which is obtained from these is actually called as the bioenergy. Now, if you consider another form of the energy, that is renewable and non-renewable sources of energy. There are different sources of energy that is renewable and non-renewable. Akshay Urja, that is actually that can be regenerated, that you cannot destroy. If you look at this figure, you can see that the organic material is obtained from the living organism, and then what you obtain is you subject it to a biodigester like biogas producer, and then finally you obtain biogas, and then the waste is all generated. That waste is actually converted into some manure or something like that, and is again used. So it is again a renewable form of energy that has been used. The biodigester for electricity or vehicle fuel production is utilized. Then you have hydroelectric power stations where you use this different form of the renewable energy. Then you can also have the different like wind energy. That is another form of the energy that has been utilized. That is actually the wind energy, and wind turbines are there that are actually producing again the renewable energy. And then you have this solar energy also, which is utilized for production of for running photovoltaic cells, and the electricity is produced. And then you have the kind of energy that is the geothermal energy that can be actually obtained, the geothermal energy for heating as well as cooling. And apart from this, you can have different forms of the energy like fuel energy, like oil can be actually utilized for the production. Then you can utilize certain nuclear energy also. So these are different forms of energy that are being utilized for the production of energy. So what we are emphasizing is actually the utilization of energy from the biological source. If you look at the energy flow, all of you are familiar that if you look at the source of energy, that is actually the sun. It produces the energy and it is utilized by the primary consumer, you can say the producers, and then the heat energy is lost in the form of the heat, then it is transferred to the consumer, and then finally to the secondary consumer, and then to the decomposer, and then heat is again lost, and the nutrients, it enters into the cycle. The beauty of this cycle is that again the nutrients are supplied to the producers, and then the cycle of the nutrient is completed. Now think of a situation when you have such kind of thing where there is the completion of the cycle and no wastage. In terms, we can say that no waste is generated. And so what is that is the energy is actually being utilized in a much efficient manner, in an eco-friendly manner. You have a 10% rule, which refers to that the amount of energy available to the next tropic level. Now, this is a very, very important concept. When energy moves between two tropic levels, 10% of the energy is made available for the next level. Now, the important thing here is that when it moves from one tropic level to another, only the 10% energy is available and the remaining energy is lost. So the main point, key point here is that greater are the tropic level and the higher you go in the pyramid, then the less energy is available. Now see, I'm pointing out the most important thing that is being utilized for the development of the biodiesels also, or for the development of the bioenergy. And the solution actually, the solution actually lies in this only, that higher you go in this tropic level, the less is the energy. Now, if you are using a particular source as a source of energy, then you can clearly see that the base of the pyramid, the producers has a greater energy as compared to the tip of this pyramid, where you consider the carnivores, etc. So actually the plants, the primary producers should be target source for the procurement of the energy if you're thinking of the bioenergy. So this actually lies the key for the development of the biodiesel or any such kind of the biofuels, biosources of the energy. So energy flow facing a technical problem, I think. So if you look at the energy flow, the energy enters the plant from the sun through the process of the photosynthesis. And then you can see that this energy is then passed from one organism to the another in a food chain. And then the flow of the energy in the ecosystem is unidirectional, because the energy lost at heat from the living organism of the food chain cannot be reused by the plant in the photosynthesis. Important thing, it is unidirectional. And during the transfer of the energy through the successive tropic level, there is a loss of energy all along the path. So this is again the important thing when you think of the energy flow. This is the energy flow in the tropic level. So what we want to say here is that we are concentrating on the producer level, which actually has say 10,000 kilocalories of energy, as compared to the upper level, that is the consumer, where only 10 kilocalories of the energy reaches. Now you want to utilize energy, just focus on the producer level. Now, if you come to the fuels, living apart from the fuels, what is a fuel? A fuel is any material that can be made to react with another substances so that it releases energy as heat energy or to be used for work. Now, the important definition of the fuel. So, the concept was originally applicable solely to use material which are capable of releasing the chemical energy, but has since also been applied to other sources of heat energy, such as the nuclear energy via nuclear fission and nuclear fusion also. These are also included in the category of the fuel, and no concept of oxidation is there. So if you look at the fuel, the heat energy which is released by the reaction of the fuel is converted into mechanical energy via a heat engine, for example, a piston, for example, any kind of, you can say, automobile internal combustion engine, etc. You can compare a respiration as well as combustion. I will not consider here, and we'll concentrate on biofuels. So we were discussing bioenergy. We know that the energy is stored in the living organism. Now, if you use that living organism for deriving an energy, you are actually using that living organism derived material as a source or as a fuel. So it should be called as a biofuel. So a biofuel, which is considered as a clean fuel, is a fuel that is produced through contemporary process from biomass. So biomass, anything derived from living organism. So a biofuel can be produced from plants, therefore they are called the energy crops, or from agricultural, commercial, domestic or industrial waste if the waste has a biological origin. Now, the two most common types of the biofuels, what we will consider here is bioethanol and biodiesel. When you speak in now bioethanol, there are biomethanol also, but we will concentrate mainly on bioethanol and biodiesel. So there are two concepts here that we'll be using. You should have an idea the biofuel classification. There are different categories of biofuels, and there are basically four generations of biofuel. Biofuel generation 1, 2, 3, and 4. Now, what are these? Biofuel generation 1, that is the first generation biofuel. This is made from wood crops or on the arable lands. With this biofuel production generation, food crops are thus explicitly grown for fuel production and not anything else. The sugar, starch, or vegetable oil obtained from the crop is converted into biodiesel or ethanol. So this point is to be noted that a biodiesel or ethanol is actually the first generation biodiesel, and it is produced using trans esterification, yeast fermentation, or related similar processes. Then you have the second generation biofuels. If you have the second generation biofuels, they are fuels which are manufactured from various types of the biomass. When you speak of biomass, so the first generation biofuel made from sugar and vegetable, arable crops. Second generation are made from lignocellulosic biomass or the woody crops, agricultural residues, or waste plant material from food crops that have already fulfilled their food purposes. Then you have the third generation biofuels. When you speak of the third generation biofuel, they are oil-rich algae that can be extracted from system and processed into biofuels. So this is another important point of consideration, that is the oil-rich algae. When we are speaking of the alternate sources for the biodiesel production, the algae is also an important source. So with the dried remainder further process to create ethanol by the process of the fermentation. Fourth generation, it includes the electrofuels and the photobiological solar fuels. So when we speak of plants material, the bioenergy that is actually obtained, here is a picture which is actually showing the various sources of oil, various sources of fats, etc., that are obtained from plants as well as the. So here you can see that you have coconut, sunflower, olive oil, maize oil, etc., peanuts. Castor oil, etc. So these are all supplementary material that are actually the important part of the food stuff. Now, the important thing is that the main thing that is obtained from them is the fats and oil. Now, remember, dear participants, that the fats and oil, actually, these terms are almost similar to them. Chemically, also, they are very, very much similar. The only difference that arises between them is the type of the degree of saturation and unsaturation. So when we speak of fats, what are fats? See, fats are solids at room temperature. They are solid at room temperature, and when they are solid, you can have an idea that they are saturated and mostly trans. So they have the trans configuration. What is the trans configuration? We will discuss in the coming slide. And mostly of them are derived from animals. And though they are they may be derived from the plants also, but mostly they are derived from animals and then increase the cholesterol level, and they mainly comes from animal food, but also the vegetable oil by process called hydrogenation. All of you are familiar with the dalda ghee or the vanaspati ghee. You are familiar with the equation hydrogenation of oil. Dalda ghee is manufactured by the process of hydrogenation of oil in presence of iron and nickel and something like that. So what is done is that it is converted into a semi-solid mass. So that is actually the fat you call. So you can have an idea that fats are basically saturated and they are solid at room temperature. For the example are butter, beef fat, etc. So derived from the animal sources, and this is the important thing, contain 9 calories per gram of energy can be obtained from the fats. The beauty in obtaining this energy from the fat in running out the automobiles is actually the development of biodiesel. If you speak of oils, as you're familiar now, it is liquid at room temperature. So when it is liquid at room temperature, then it is unsaturated fats, like it may be monounsaturated, polyunsaturated, or its types, etc. Mostly derived from the plants. It improves the cholesterol level and mainly comes from fats from plants, and the fish liver oil, etc. are also example, and the vegetable oil, fish oil also contains the 9 calories per gram of the energy. Some compounds that are soluble in the organic solvent and mostly insoluble in water are called fats. Fats that are liquid at room temperature are called as actually oils. That is the basic difference. Now see, oils and fats form an important part of the healthy diet. Now see, structurally they are esters or the esters or the glycerol with 3 fatty acids called as either triglycerols or the triglycerides. This is the heart. This is the base of development of the biodiesel. Now, by using this process called as the transesterification. As such, they are scientifically called triglycerols, but are commonly referred in the food industry as the triglycerides. If you look at the structure, this is the structure of a molecule of glycerol. You can see that it has 3 OH group. And if you speak of the fatty acid ester, also triester, it has structure similar to like this. You can clearly see that these are actually, this is actually the molecule of the glycerol. And this you can say that the 3 fatty acids, they are actually forming the 3 ester groups with this. So that is actually the triester linkage that is formed with this and the triglyceride. So the term lipid, which is broadly considered fats and oils, is a category of this, and any substance of biological relevance composed of carbon, hydrogen, oxygen that is insoluble in water but soluble in the non-polar solvent. In this sense, beside the triglyceride, the term would include several other types of the compounds like mono and diglycerides, triglycerides also, phospholipids such as lecithin, sterols like cholesterol, waxes such as B waxes, and free fatty acids, which are usually present in the human diet in smaller amounts. Another important thing, now I am discussing this because when you have an idea of what is a transesterification, you should be clear about the fatty acid. As it is informed by Dr. Anu Sharma ma'am, it is a multidisciplinary class, and there are certain faculty from this non-chemistry background also. So fatty acids. So fatty acids, you can see it is comprising the word acid, so it should have a COOH group, as well as the fatty acid, the long hydrocarbon chain should be present. So it has a COH group as well as an alkyl group that is present, namely a chain of carbon atom which is joined by single, double, or more rarely triple bond, with all remaining free bonds filled by hydrogen atom. If you look at the structures of fatty acid, how to name them, the fatty acid, then see, this is actually how you name a fatty acid, a very important aspect. For example, you say C12 semicolon 2. So for example, N is the number of the carbon atom, D is the number of the double bonds, and triple C, as it is the list of the position of the cis or trans double bond, TTT, that is the trans double bond. We will see an example how we are named here. And fatty acid. See, this is a fatty acid, linolenic acid, L8. It is named as C18 semicolon 2. Now C18, C refers to the number of the carbon atoms in the carbon chain, remember, in the carbon chain. So it is 18 carbon fatty acid molecule, and the 2 refers to the number of the double bond that is actually present. So it is N6. You can see that or omega 6. This is the omega or nomenclature. Starting from the other end, it is actually the 6th carbon atom, which actually poses the unsaturation, the first unsaturation. So it is named as, it is an essential fatty acid, the linolenic acid. Then you have a good source from the flaxseed, that is the alpha linolenic acid. You can clearly see that it is C18.3, consisting of the 18 carbon atoms. And then finally, you can see that finally it has the fatty acid molecule, and the 3 double bonds are actually present in this. And see the oleic acid, the important acid, it is present in the peanut, soy oil, etc. Now there are some other examples also. The codes for the stearic oleic acid should be 18 semicolon 1, 18 1. Now This is a very, very important classification when you go for the research purpose and all. Whenever you see literature, you will have this fatty acid profile of a particular oil. And even when you purchase some vegetable oil from the shop, you will see the label that consisted of this kind of the label. You go for the GC mass also, then you will have the same kind of the composition as it consists of C18.1, C18.2, etc. or not. So this is an important classification code for this. So alpha oleostearic acid, it is named as 9E11E13Z. That is actually the chemistry person can easily understand. It's a type of the E and the Z type of the orientation, that is an octa deca 91113. Trienoic acid in the IUPAC nomenclature, simple 18:3, trans 911, cis 13. So you should have an idea when you go for the classification, when you go for searching the type of the fatty acid profile. One point more I want to emphasize here while discussing these biodiesel is that whatever be the plant source, whatever be the animal source from which an oil is obtained, the oil profile is actually the different, but the number of the components can be same. What I mean to say is that the oleic acid in all kind of the oils that is derived from whether a peanut, from a coconut, from a mustard, from a sunflower, then what is the difference? The difference actually lies only in the type of percentage composition of these respective oil. In some of these oil, some of the oil you will see, say for example, the percentage of oleic acid is high and the percentage of the oleic acid is less in the another oil. That is what makes a difference between one oil from another, and also from health point of view, the cis and trans composition is a very, very important factor. So you can classify a fatty acid by taking the help of chain, that the chain length, they can be short chain fatty acid, they can be long chain or the medium chain fatty acid, they can also be a long chain fatty acid. For example, you have different acid, then very long chain fatty acid. They can be saturated as well as unsaturated fatty acid also. For example, saturated means they do not have any kind of double bond. So the saturated fatty acid, if you speak, it is actually the cis mono unsaturated, then actually mono unsaturated, then poly unsaturated, and then trans fatty acids. In very broad term, saturated fatty acids and trans fatty acids are solid at room temperature, while the cis unsaturated are liquid at room temperature. Then you have the degree of unsaturation also. Then we'll move to the next slides, continuing with the other. So we'll not go for the health aspect. We will simply consider what are actually the various structure. So now what we are considering is that you have a structure of the fatty acid, and found in most commonly consumed oil and fats are composed of long carbons and hydrocarbon chain, typically consisting of 8 to 20 carbon atoms, mainly with even number of carbon atoms, although the animal fats are also contains the significant levels of the odd chain. They have a methyl group at the one end and the carboxylic acid, and double bonds in the trans. Now this is very, very important fact, because this is actually the key point why we are actually considering these oil as a source for development of the biodiesel. So when you consider the trans fatty acid, these are the most commonly found as a result of either hydrogenation of the fats or by holding fats at a very high temperature, that is 200 degrees centigrade, for extended period of time. See, what I mean here is that when you are using an oil in kitchen for deep frying purpose, you are actually heating, you are continuing heating, you are repeating the process of heating. And what happens is that whatever quality, good quality oil is there, the configuration of the oil changes from cis to trans. And when it changes from trans, then what happens is that it is not good for health purpose, and it results, it's not good for heart. As such, they can gradually be produced, build up in refined oils. So the trans fatty acids are also found in some natural milk and meat of the ruminant animals such as cattle also. So the important thing here again is The typical natural trans fatty acid level in cow's milk. These are the different fats that are biologically available. We will not go into detail, but the trans fatty acids are found to have even the worst effect on our health. The chain length of a fatty acid increases with the melting point, and then some facts, if you consider, then also it is related. See, prime. So saturated fatty acids and trans fatty acids have a much higher degree of oxidative stability than do the cis unsaturated fatty acids. The main choice of oil for fatty acids are the palm oil, olein, which are acceptable susceptibility but contain 40% saturated. Sunflower oil or rapeseed oil, much lower stability, much lower saturates of the high oleic variety of the sunflower oil. We can go, there's a lot of literature available which oil to be used for the cooking purpose. There are many medical reviews which are available. We are only interested in the waste oil that is actually generated, and that is clear cut that the oil that is actually you are using for frying, and after a number of such operations, the oil is not suitable for the purpose of cooking. So some fatty acids, notably trans and saturated, increases the blood cholesterol level, the bad LDL cholesterol levels. So the low density level cholesterol levels and the increase in the blood cholesterol level, again particularly LDL cholesterol level, increases the risk of the cardiovascular diseases. Therefore, the consumption of the trans and the saturated fatty acid increases the risk of the CVD. So the cis unsaturated fatty acids, and there are. Now we'll emphasis on the point that is actually the fats and oils that has to be used as fuels. See, vegetable oils are used to make biodiesel, which can be used like conventional diesel. The most important thing, the vegetable oils can be used when you are using the raw vegetable oil. That is actually called as the neat vegetable oil. But it has a very great problem of the viscosity and further the oxidation. The vegetable oil gets oxidated, gets converted into some harmful product. Some vegetable oil blends are used in unmodified vehicles, but straight vegetable oils, which we call as SVO, also known as the pure plant oil, needs specially prepared vehicles which have a method of heating the oil to reduce its viscosity. So the use of the vegetable oil as alternate energy is growing, and the availability of the biodiesel around the world is increasing. So now, what is the need of actually utilizing this vegetable oil as actually a biodiesel for running the vehicles? It is actually the energy crisis. It's not only the 2010 studies, but it is also the recent studies which are published that in the journal, the energy policy by researchers from Oxford University predicted that demand would surpass the supply by 2015. That has already passed, and we are seeing that the price of the petroleum, the price of the LPG, etc., they all have risen up, and they are forced by strong recession pressures caused by the reduced supply and the government interfaces. So there is a need, there is a so there is a need. There is a critical situation has led to the emergence of an eco-friendly, I repeat, alternative fuel biodiesel combined with a growing demand significantly increases the worldwide. Most important concerns are the availability and price of the liquid fuel for the transportation, price of the petroleum derived product. Now, these are some reports which are actually published, and all are familiar that there is a consumption from 1990 to 2040 in quadrillion BTU. And so production and consumption of the petroleum product, if the analysis is also carried out, it clearly indicates that there is actually a great need. There is an energy crisis. So what is the now, this is actually what we want to say is energy balance. Now, what is energy balance? If you speak of energy balance, see, the ratio of comparison of the energy stored in the fuel to the energy required to grow. In simple words, what you have an expenditure for production of a particular source for production of the fuel, and as compared to what you are utilizing it. So the ratio of comparison of the energy stored in the fuel to the energy required to grow that particular product. So that is actually called as the energy balance. And see, if you look at the energy balance, then the energy balance of the ratio of the biodiesel is no less than 2.5 to 1. So this is again important. This is again a very important factor which actually forces us to think of biodiesel as an alternate source for production of energy. So again, we will move on to explaining this fact that the well-organized storage of the biodiesel can provide energy security to our country. So what is actually biodiesel? Biodiesel refers to a processed fuel resulting from the biological source, and it is equivalent to a petrodiesel. Biodiesel can be produced from a variety of sources like a plant oil, animal oil, plant oil, animal oil, cooking oil, used vegetable oil, and the other similar sources. So, two important things. First, bio, that is to living organism. Petrodiesel, so you are naming it as a biodiesel. And the important thing, by definition, is that it is used by the process of trans-esterification. That is actually the important thing. So the process of trans-esterification, because so biodiesel refers to is defined as exclusively as a monoalkyl ester of the long chain fatty acids, which is derived from the oils, fats of the vegetable, and animal oil that fulfill almost all the requirements of the petroleum derived diesel. So it is now clear it is a monoalkyl ester of a fatty acid produced from both edible and non-edible vegetable oil. Point to emphasis here is that when we are speaking of edible or a non-edible vegetable oil, it is an trialkyl ester. So you are converting it into a monoalkyl ester. So various other biofuels are there like methanol and ethanol. They are biofuels. What we are speaking is biodiesel. So it is obtained by the process of trans-esterification. Trans-esterification, also known as alcoholysis, because alcoholysis refers to lysis with the help of alcohol. You are breaking down a complex molecule into simpler molecule with the help of an alcohol. It is a kind of the displacement of one alcohol from an ester by another alcohol. This process has been widely used to reduce the viscosity of triglyceride. The trans-esterification reaction is represented by a general reaction. If you look at the reaction, see it is like this. This is actually the reaction that we can see for the production of the biodiesel. See, this is actually a molecule of glycerol and the three fatty acid molecule. They have joined together and they have resulted in the formation of a triester. So triester, because it is a triester of glycerol, so it is actually called as the triglyceride. In red, you can see the three molecules of the alcohol. The three molecules of the alcohol may be ethanol, methanol, and then you have a catalyst. There are a number of catalysts. The catalyst can be acid catalyst, it can be a basic catalyst. See, when you are speaking of the catalyst, it can be an acidic catalyst, it can be a basic catalyst. So what is there is that when the reaction is carried out, the glycerol molecule, you can see the glycerol molecule is replaced. This glycerol molecule is actually replaced by another molecule and it is converted into a free glycerol molecule. So yeah, this is how it is obtained. And in another equation, you can see that the triglyceride molecule, it combines with methanol in the presence of the catalyst and it gets converted in the form of the three fatty acids, and they are actually called as the fatty acid methyl esters, commonly known as FAME. That is FAME, and a free molecule of the glycerol is obtained. This is the basic equation which is actually utilized for the production of biodiesel. So the basic general equation which is actually utilized for the production of the biodiesel. What we have performed experimentally, these are the important data. For example, we have taken a base trans-esterification process. So potassium hydroxide, say about 2 to 2.10 gram, and methanol. Then we have mixed this in with the 300 milliliter of oil. We have taken the oil, and then with the help of the mixer for 10 minutes, with the help of the magnetic stirrer, converted into the solution for stable condition for 1 day, and separated the glycerol and free acid methyl ester, which is actually the biodiesel, and the use of the same as alternative fuel, diesel engine, which can be experimented with by the mechanical department. This is actually the collaboration, how you can carry it out in your college involving students. So electric loading arrangement is there, and this is how using a separating panel, you can actually separate the glycerol, the fatty acid, the emulsion formation takes place, and it is very, very difficult to emulsion, though there are certain de-emulsifiers which are actually used. This is actually the magnetic stirrer, which is actually utilized. Due to the technical problem, I have to share this on the camera, otherwise the picture would be more clear to you. And this is how the biodiesel separation it appears, and this is the two layer, and the oil without treatment looks like this, and then this the groundnut oil we actually use for the purpose. This is actually the experimental machine available in the mechanical department, Engineering College, Bikaner. The performance of the engine is described as how efficiently engine doing work and how engine behave with different loading conditions. Now, again, the question arises, why biodiesel? See,
Sir, are you able to hear me, sir? Sir?
lipids and to help flow range from small single-cell
Sir, your voice
species.
is breaking up. Sir, your voice is breaking up. Sir? You are not audible, sir?
No, I
Praveen,
was
sir?
talking to you. I was talking to you on
Okay,
phone
okay.
because I got a call. Okay,
Okay, sir,
now
okay, sir.
so alternate source, you can see that now what is an algae? You can say algae is a very, very you can small plant in a general term. It's a small plant that actually grows in the in water, and the microalgae. There are two different classification. But when you are speaking of algae, the importance of thing is that it solely depends on photosynthesis for its life. Now, photosynthesis actually requires carbon dioxide and water. It grows in the plant area where there is plenty of plant, plenty of sunlight, plenty of carbon dioxide. So it can utilize and convert it into some form that is actually the lipids, oil, carbohydrates, starch, sugars, and many other materials. The important part of the algae is that now the percentage of oil that is obtained from algae is very high. It is say about 60% as compared to the traditional, as compared to the normal oil that you're obtaining from these oil-rich seeds. That is only about 30 to 40%. So this is actually another point of emphasis that it should be done. If you look at the type of the algae, there are a variety of algae. For example, you have red algae, you have green algae, brown algae, then you have diatoms, then you also have blue algae, dinoflagellates, etc. So there are a variety of, just a minute. There are a variety of such algae which can be actually you can see. So algae, if you look at the energy point of view, algae produces 6,000 to say about 10,000 gallons per acre of oil as compared to the corn, which produces 340 to 420 gallons per acre of land. So if you look at the algal biomass fractions, products and markets, you can clearly see that there is a greater contribution from algae as compared to the other feedstocks. So biodiesel history, if you look at from 1978 to 1996, the US Department of Energy funded a program to develop the renewable transportation fuel from algae. The main focus on the program was known as the Aquatic Species Program, ASP, production of the biodiesel from the high lipid content algae grown in the ponds, and it utilized only the carbon dioxide from coal-fired power plants. Why make it a fuel? So these are the important points. Algae can be used to make biodiesel because it produces very, very large amount of the oil when compared to the terrestrial crops grown from the same purpose. Algae contains say about 2% to 40% the lipid oil by weight. Once harvested, the oil can be converted into fuels for transportation, aviation, or heating. High growth rate and easy to grow. It has a very, very high growth rate. The cycle of life cycle is very short. You have different algae growing in different regions. For example, in warm seasons, there are certain species. In cold seasons, and the use of the diatoms and the green algae. So harvesting biodiesel, if you want to harvest biodiesel, there are different methods. See, you have certain ponds where algae is grown and then it is then actually collected. Then you can have these kind of the less complex structure. You can use the microalgae for propagation, less complex structure, faster growing rate, high oil content. And then you can have the open pond system. It can be difficult. Type of the algae has to be hardy and can be less hardy and grow slower. Then you can use bioreactor tubes also for existing infrastructure, provide the raw material for the system like carbon dioxide nutrient, changes those waste into resources. How to get the oil? You can get the oil by the normal process, that is expeller press, that is dry the algae. Oil content can be pressed out with an oil press and it extracts to 70 to 75% of the oil out of the algae. So hexane solvent method, that is a solvent extraction process. It uses the chemical like hexane and methanol, can be harmful and explosive. Can cold press and hexane solvent extract 95% of the oil. Then you can have the supercritical fluid extraction method also. See, this is actually what the raw material is used by an algae. So look at the raw material that needs to be used by an algae. It is only carbon dioxide, water, and sunlight. You can utilize, you can grow it in the lab also, as shown here. And oil yield, if you compare the oil yield, you can say corn and then microalgae, it is 1850 based on the actual biomass yield. And the microalgae, it produces about 5,000 to 15,000 theoretical laboratory yield. So it is a great yield obtained from the algae. Now, if you look at the bioreactor that is actually utilized for the production of oil and then finally biodiesel from algae, you can have the gas and the water conditioning, that is the carbon dioxide and the nutrients are supplied to a big tank or actually the incubator or the bioreactor where you are growing an algae. The algae grows and then you actually harvest the algae as the biomass and then you subject it to the process of the oil extraction and then the oil is extracted. Important thing here is that when you have extracted the oil, then you the waste that is produced, the biomass that is produced, is actually not a waste. It is the source of many other material like medicines, like carbohydrates, very many other chemical compounds. Efficiently, it can actually extract oil as well as the other material from this. The original system, you can see that this is actually the algal stock, and with the help of water, you have an incubation tank, and then you subject it to a controlled nutrient condition. That is actually the bioreactor network, and then actually the algae is grown, and finally, then you have a tank and this algal oil as well as the components, so various components like fermentation, you can obtain ethanol, you can use as a feed, you can use various material. So this is actually the ponds, the algal growth system, where you can actually you can see that the big fields they are grown, and then it is actually the harvesting of the algae by the process of the filtration, and then they are subjected to centrifugation process and all, and then it is actually extracted. These are certain incubators they are where this algae is being actually harvested, and then finally they are grown and ultimately subjected to optimum condition of the carbon dioxide sunlight, subjected to carbon dioxide, sunlight, etc. So it can be collected. So these are actually a pictorial diagram of how it has been, the algae is actually grown. Then how you can actually subject it to industrial purpose. So the important thing is that the simple experiment that can be carried out in our laboratory using the biodiesel production. The main thing here is that when you are speaking of biodiesel, when you are speaking of this kind of production, the important thing here is that it is actually the calorific value. That calorific value should be measured, and when you're speaking of the calorimetry, it is actually the measurement of the calorific value. That is actually the heat generated per gram of the substance. And it is used to measure the amount of heat transferred to or from a substance and a device. And you have different types of the calorimeter. And what we use in our lab is actually a simple calorimeter that is actually called a bomb calorimeter. And this bomb calorimeter, if you look, it's an adiabatic bomb calorimeter, estimate the loss surrounding to it, and it uses the constant volume and noted. And see, by using this, you can calculate the high calorific value and the low calorific value of the particular fuel. What we want to say is that the biodiesel has been prepared. You have to determine the calorific value, and against the standards that are actually mentioned by the government, the Bureau of the Indian Standard, you have to match them. So there are certain specifications, that is the biodiesel specification, that needs to be matched, and then only you can say that the biodiesel that is produced can actually cope up with that. So this is actually a theoretical relation and the description of calorimeter that you can see. It has a sample placement bomb where you ignite the substance that's look like this. And this is actually a very, very simple instrument which can every chemistry lab in the engineering college has. And using this, you can actually produce research papers by changing the feedstocks by changing the feedstocks from the various feedstocks and by varying the compositions of that particular thing. This is a stirrer, a calorimeter, a temperature recorder that is available in our laboratory. See, it's basically a copper calorimeter that is actually used, and using the simple theoretical calculation, you can actually calculate HCV and LCV values. So using these HCV and LCV values, it can easily be calculated how the substance, and theoretically also by using the Dulong's formula, we can easily calculate the calorific value of a fuel. So you from obtaining. Now the most important thing again here is that when you are producing a biodiesel, when you're using a pure vegetable oil, the sulfur content is very, very less, and even you can say zero. So that is very useful for generating such kind of thing. So I'll continue with the next slide also. Uh, just a minute. Just a minute. See, this is again kind of, you can say, a marshy area that is very close to a very famous school. That is actually the uh, Rayan Public School. I should not take the name, but it was only during the initial stage when it was made and very close to our college. So the place you can see that the algae has grown here. Now this is actually how the algal bloom that grows when in favorable condition is available to this. So this algal bloom, we harvested the algae from here and collected it and finally filtered by and then extracted, and then the oil was actually utilized. And the second important thing is that the another picture that is of the frying oil that all of you actually might be using in your this particular household in the kitchen. So when you are using this kind of thing, see what is there is just a minute. When you're using this, when you're using such kind of the oil, then and you can go on keep deep frying this kind of the oil. You will observe that on deep frying such kind of the oil which is present in the cyst form of the acid that actually gets converted into the trans form of the fatty acids. When it gets converted into the trans form of the fatty acid, it is actually not useful for us. So it is not useful for us. It means that it is of no use. So when it is of no use, it should not be taken for the healthy purpose or for cooking food. So that is another source where it can be utilized for the preparation of the biodiesel. So when you are using it for the production, when the waste oil is used as a production of the biodiesel, it is actually the important, it is actually important, you can say, aspect, which can be actually considered, which can be actually, we can say, considered for production of the biodiesel. If you look at the national oil mission by 2030, the खाद्य तेलों के मामले में आत्मनिर्भर बनने का लक्ष्य. We will be self-sufficient in these edible oil by the 2030. No problem. We have plenty of this edible oil. But what I want to say is that when you're using an edible oil, you have a limit. In Bikaner region also, we have a number of such kind of the food industries, and you are using such kind of the food industry. You are producing the snacks, the bhujia, papad, etc. using these oil, and you are frying these oil. You are using for frying purpose. So there is a limit of utilization of oil for the heating, and then after heating, it gets converted into form which cannot be used for cooking purpose. So that then it is actually converted for this kind of say production of the biodiesel. Similarly, we know that energy crisis is there. And using the conventional 19, सबसे गर्म दशक, the most you can say the hot decade. So it was the hottest decade from 2010 to 2019. So it is again an alarming situation, and the ultimately source is carbon dioxide. When you're using a biodiesel, the carbon dioxide that is being generated by biodiesel is again utilized by the plant. So it enters into the life cycle of the plant again and enters into the biodiesel. So what is theoretically said is that it has a zero carbon emission. So it is again another important support you can say, for the process. If you look at the extent of the pollution, you can see that the pollution in Rajdhani Jaipur 4017 QSI, that is the quality index, पहुंचा वायु प्रदूषण का असर. सो जयपुर में एक दिन में 14 और दिल्ली में 22 सिगरेट जितना धुआं निकल रहे हैं लोग, the people are engulfing about say 14 to 22 cigarettes equivalent smoke in daily life, and that is nothing only because of the biodiesel. So pollution is really a great problem, and the poisonous gas is also produced by, you can say, the smog, etc. So there is a need to critically analyze it. There are certain reports also. For example, all of you are familiar with the type of the news that is actually produced. That is, if you are utilizing coal for the production of the energy, you are paying. Now the recent report is that you are paying 5 rupees more as compared to the nearby states also. So these are all alarming situations, and you need to have an alternative, and the biodiesel is actually such an alternative for this kind of the process. And see what just a minute. And what we want to say is that when you are using a biodiesel, it is not simply a trans-esterification. It is not simply a trans-esterification process that needs to be carried out. There are certain standards which are mentioned by Government of India. That is actually the biodiesel B100, that is the fatty acid methyl ester, and this is actually the fatty acid methyl ester FAME specification. That now see, this is important thing. When you're speaking of B100, it means that the pure fatty acid and the blended oil is being utilized, that is B10, B5, B25, B20, etc. And we have certain reports regarding this. When you are see when you're using when you're using the biodiesel, the cooking oil से बनेगा biodiesel. So about the project has been started in 100 of the cities, and each year it is about estimated 110 crore liter of biodiesel production. That is actually, the report is not recent, and it's 5-6 years back. So Delhi को रोज 10 lakh liter biodiesel, it is available. These kind of the reports are available at the government side, the Ministry of these non-renewable energy resources. उपभोक्ताओं को सीधा बेचा जा सकेगा बायोडीजल. There are policies of the government where we can utilize them, and in order to promote the biodiesel production. So there are certain pilot projects also where the certain vehicles, they are actually run using the biodiesel. So this is again another step, trying for finding out the alternate sources for the energy. And there are certain petrol pumps also which are available, which sell actually biodiesel. For example, Rajputana Speedway Fuel LLP, near this, you can say, Nal area. And then, as I explained to you, biodiesel is a clean burning fuel which can be actually utilized, and you can have the various sources of energy, various alternate sources also for the production of the biodiesel. So it is actually a great fact that the biodiesel is environment friendly. The second point is that when you are using various sources, you should have certain alternate sources so that the biodiesel production can be carried out. It is actually, you can see there are a number of experiments that is actually performed by our students also in the college, and this was a report which was published where actually we had carried out an experiment where the level of the pollution was being checked by our MSc students. We run MScs also, and it was carried out by a very simple experiment where actually what they did was they used a certain paper where then actually placed at various places like petrol pump, railway stations, and the various regions of the Bikaner for 24 hours. And then for after 24 hours, the samples were collected, and then we weighed them sample and then analyzed them, and the extent of the pollution level by increasing the weight mass of the substance which are deposited on the smeared this was actually calculated. Now by using this what we want to say is that a primitive idea regarding the area where much pollution was there was being pointed out, and to public. The main aim was to make aware of the public, and then they also published. So the paper also got the first position. So what I want to say is that we should initiate students to carry out such small activities which does not require very high infrastructure, very high research facility. We should trigger them to carry out such activities. For example, in your college level also, no doubt you might be having many sophisticated instruments also, but when you are carrying out certain activities, you should initiate students to carry out these grassroots level activities where they can be motivated to carry out the activities. Then we had a MOU with Maharaja Ganga Singh University regarding the production of biodiesel, and we have a biodiesel research station established with Maharaja Ganga Singh University, where we are producing the biodiesel with the help of the enzyme hydrolysis also. A lipase enzyme is actually used, and Professor Gautam Meghvanshi has been using. And then this is Honorable VC sir, with whom we had the MOU with them. And this is our Department of Chemistry, where you can see this is our research lab, as well as for the BTech and the MSc lab. And these are the glimpse of instrument that we are having in our lab. And we are carrying out these kind of instruments are used. And these are the students, our team, where we are carrying out various kinds of the activities. So now, thank you very much, and really, I'm thankful to all of you that very patiently, all of you have all of you limitation that I was facing. Though I may level best to resolve this issue, but I couldn't help it out thank you, ma'am. Thank you.
Yeah, thank you. Thanks a lot, sir. Thank you for the wonderful lecture. You have explained in a very beautiful manner the importance of biodiesel, its structural level combination, and all the factors which we can consider about biodiesel facts. And these are whatever basic components we can have, and various resources as you have discussed. In today's era, this is very important source of energy, reusable energy. So I thank you on behalf of FDP team for this wonderful lecture. Thanks a lot, sir. Thank you so much. And
Thank you, ma'am.
participants, if you have any queries, you can post it in your chat box. If you have any queries, you can post in chat box. I think, sir, there are no questions coming out of this.
Okay, no
But
problem.
I
Mail
sincerely
IDs there,
thanks you, sir, for please share your mail ID so that if anybody has some questions, they can ask you directly, sir.
yeah, definitely, ma'am, definitely. Thank you, ma'am.
Thank you so much. Thanks a lot. Due to some technical glitch, it happened, but it was really very nice session held by Dr. Praveen Purohit, sir. So I declare the end of the session, and the next session will start by 2:30 p.m. Thank you so much, everyone.
Thank you, sir, and thank you, ma'am. And thank you all the participants for your kind support. Thank you very much. Now, next session, as ma'am said, next session is at 2:30 p.m. Thank you.